Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to help you get started with Python, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. I'm gonna tell you why you need to learn Python. It's the easiest programming language to learn, as well as being the most popular in the world right now. And according to Glassdoor, the salary for new Python developers in the United States is $64,000. If any of this sounds good to you, well then, let's get started. If you need to download Python, go to python.org/downloads and click this yellow Download Python button. Open when done. Check Add Python 3.9 or another version to path. Install now. And then give it a little bit. It states here that setup was successful, so let's close out of this. Our next step is to download an IDE. That's an acronym for Integrated Development Environment. Think of it as software that helps us write other software. One IDE that I recommend is PyCharm. You can find it at jetbrains.com/PyCharm. Go to download. If you would like to pay for a professional version, you can click this download button. But since I don't like to pay for things, I'm going to use the free community version. At this point, we just have to follow the standard installation procedure. Click Next. You can pick a destination folder, but I'll keep the default. Next. If you would like a desktop shortcut, then check this. I would also recommend updating the path variable. Next. Install. And then give it a minute or two. Then after finishing, I have a desktop shortcut, so I can just click on this to run PyCharm. Let's create a new project. Name this project whatever you like. I'm going to name this project Hello World. And I recommend not creating a main.py welcome script right now. I'll show you how to do that manually. And let's create. If you need a Python file to work with, this is how to create one. Go to File, New, Python file, and I'm going to name this main, and then click Python file. Alright, ladies and gentlemen, we now have an empty Python script that we can use to begin coding. Now, if you checked this box, create a main.py welcome script, and then created a new project, then your main Python file will probably look a little something like this, but that's completely fine. We can just delete this. I don't know about you guys, but the font is very small for me, so let's change that. We can change that by going to File, Settings, Editor, Font, and you can increase the font size. Let's say 25. You can also change the font too. What's a good one? How about that? Then click Apply and OK. Much better. We can actually see something. To run a Python script, just click this green play button in the corner. Alternatively, you can go to the Run tab and then go to Run. Okay, so this box that appeared at the bottom, this is referred to as a terminal window. This will display any output that your program has. And this line at the end, process finished with exit code 0, that just means that there were no errors in this program. So currently this program doesn't do anything, but let's change that. Let's print something. Let's print a message. So to print a message to the terminal window, type print, and then add a set of parentheses, and then you can type a message, but it has to be within quotes, either double quotes or single quotes. It doesn't matter. So let's think of a message. I don't know. I love pizza. Then let me run this. And in my terminal window, it says, I love pizza. To print another line, just add another print statement. Print, and then your message within quotes. It's really good. And well, what do you know? It printed, I love pizza, it's really good. So ladies and gentlemen, you just wrote your first Python program. By the way, you can change the font as well as the font color of your terminal window by going to File, Settings, then go to Editor, Color Scheme, Console Font, and Console Colors. Let's change the font. Let's say I would like whatever this font is, then click Apply. Let's change the font color too by going to Console Colors. For any output, you can click number 2 and select a color. Let's say I would like bright green. That should be decent. And for anything else, let's say this will be a dark color so I can barely see it. So then let's click apply and OK. Oh yeah, that's much better. Well, everybody, that was your very first Python program. I'll post any useful links and timestamps for this video in the comments section down below. But yeah, welcome to Coding with Python. Hey you. Yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how variables work in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, let's do this. A variable is a container for a value. It behaves as the value that it contains. It's much like in algebra lessons back in the day where we had to solve for whatever value x was, and then we can reuse x and it behaved exactly as that value. Well, with programming, we can do that, plus we can assign variables of different data types, so they are not limited to just numbers. We can assign whole words, numbers, and even these things called booleans, which are either true or false. But I'll get more in depth into data types a little bit later on in this video. So let's create a variable, and this is how to do so. We need a unique name for this variable. Let's say name. Name equals some value. Now the first data type that we'll cover is strings. A string is a series of characters. So to create a string, we can either use single quotes or double quotes in Python. And we can assign this a value of whatever your own name is. So I will assign this variable name a value of bro. Now this variable will behave exactly as if it was this value, this name, and then we can reuse this variable for something. So let's print whatever our name is. Print name. And this will print whatever your name is to the console window. Now when you print your variable, make sure you don't put it within quotes, because what we're doing then is literally printing the word name, as you can see here. So if you need to use your variable for something, make sure it's not within quotes. Now we can combine our string variable with another string. So within our print statement, let's print a string literal such as hello space plus name. So we are combining strings, and then we're printing the result to the console window. So this will print hello bro. Now you can actually check the data type of a variable. So I'm going to turn this line into a comment. So what you'll do is take the name of the variable, surround this with a set of parentheses, and then precede the set of parentheses with the type function. And this will print the data type of this variable to the console window. And you can see that it says class str, short for string. A string is a series of characters. A name is a good example of a string, a series of characters. So that is how to check the data type of a variable. Just use the type function. Now you can actually combine variables together as long as they're of the same data type. So let's change our name to maybe first name, and we'll create a second variable called last name. Now a common naming convention with variables, if it has 2 words, separate each word with an underscore. It's not necessary, but it's common practice for Python. And honestly, I sometimes forget about that, but don't tell anybody. So let's create another variable called last name. Last name equals whatever your last name is. And then let's create a third variable called full name, full underscore name. And let's combine first name plus last name. And let us display full name along with hello plus full name. Now, these 2 names were combined together to create a whole new variable. Actually, what I think I'll do is add a space within my variable. So I'm doing a bunch of string concatenation. I'm combining the variable first name plus a space character plus last name. So the result is hello, whatever your first name and last name is. So that is a variable of the string data type. It is a series of characters. Now, with strings, we cannot normally use these for any sort of math, That's where the next data type comes in. For the time being, I just turned all of these lines into comments, and we are going to move on to the int data type, short for integer. This time, let's create a variable called age, and we will assign this a value of whatever your age is. Let's just say that I'm 21. Now, when you assign a value of the int data type, make sure that it is not within quotes, because then technically it would be a string then, and you can see that the color scheme for this number actually changed. So if this was a string, we would treat it different than an int data type, because with strings, we cannot normally use them for any sort of math. So we now have a variable called age, and we can actually increase or decrease or do whatever we want with the age. Let's increase our age by 1. Let's say it's our birthday. To do so, we would say age equals age plus 1. And then let's print our age to the console window. Print age, and you can see that it says I am 22. Now there's a shorthand way of writing this. What you'll do is type age plus equals 1. So that's kind of like a shortcut, and this would work the same too. Now let's print the data type of our age variable because we can. Within a print statement, I will print the age and add my age variable to this type function, and this will print the data type of my age variable to the console window, and I will turn this line into a comment just so that it doesn't get in the way. Now, if I were to print the data type of my age variable, as you can see, it is of the int data type, short for integer. It only stores a whole integer number. Now, what if this was a string? So what I'm going to do is surround my value within a set of quotes, and I will turn this line into a comment so that it does not get in the way. You can see that the data type of my age variable is now a string. And with strings, we cannot normally use them for any sort of math. So let's attempt to increase our age variable by 1. And we ran into an error, a type error. Can only concatenate string to string, not int. Now the point being is that it's important to use the appropriate data type, because with strings we cannot normally use them for any sort of math. You'll want to use a data type of a numeric value, an int or a float, which we'll discuss a little bit later. Now here's a situation to consider. What if we would like to display our age variable along with a string literal, much like what we did with this line involving a string literal such as hello plus the user's full name. So let's attempt to do so, and this is not going to work, and I'll explain why. So within our print statement, let's say something such as your age is plus age. Now we're going to run into a type error. That's because we attempted to use string concatenation with a string literal and a variable of a different data type, a variable of the int data type. In order to display our age along with the string, we would need to convert our age variable to the string data type. And one way in which we can do that is by typecasting, and we'll cover this more in the next video. So we're going to surround our age variable, that is of the int data type, with a set of parentheses, and precede this with str, short for string. And this will convert our variable to a string that will allow us to display it with another string. Now, if we were to run this program this way, this will now display your age is, and in this case, 22. So if you need to display a variable of a different data type along with the string, you would just need to use a string cast to convert that data type to a string. But we'll cover this more in the next video on typecasting. So that is the int data type. It stores a whole integer number. And the next data type is the float data type. And I'm going to turn these lines into comments and we can move on. Now, the float data type is a numeric value that can store a number that includes a decimal portion. An int data type cannot store a decimal portion. That's why it's int, short for integer. It only stores a whole number. This time, let's say we have a height, and I will assign this a perfectly normal height of maybe 250.5 centimeters. So this decimal portion is important. That's indicating that this is a floating point number, a float for short. So let's print our height to the console window. Print height, and this will print whatever my height is. And now let's check the type of our height using the type function. So within a print statement, I'm going to add my height, surround this with another set of parentheses, and precede this with the type function. And the data type of my variable height is a float, short for a floating point number, a numeric value that contains a decimal portion. And now for practice, let's print our height along with a string literal. So let's create a string literal such as your height is plus height. but guess what? We're going to do some typecasting. So surround height with a set of parentheses, and precede this with str so that we convert height to a string so that we can use string concatenation within this print statement. And this will print the message, your height is 250.5. Actually, let's add centimeters to the end. So plus cm. And there we go. And that is what a floating point number is. Float for short. It is a numeric value that contains a decimal portion. Now, the last data type that we're going to cover is the Boolean data type. It is a variable that can only store true or false. Let's say we have a variable called human. If we were to assign this a Boolean value, this would be either true or false. And we can print whatever this value is. Let's print whatever human is, and this will display false. Now, the reason that you may want to use Booleans instead of strings, even though you can still store a string representation of the word false or true, is that these are very useful when we get to if statements. We can check to see if some statement is true. So that is a good use of Boolean values. Now let's check the data type of my human variable. So let's print type human, and this will print to the console window bool, short for Boolean. Now make sure you're not putting this within quotes, because then it's technically a string and they behave differently. Now the data type is a string, and you may have noticed as well that the font color has changed between strings and Boolean values, so that's another good indicator. Now what if you need to display your value along with a string using string concatenation? Well, guess what? We're going to typecast again. So let's print something. Are you a human? So we need to use string concatenation. So I will convert my Boolean variable of human to a string. And I have been programmed to inform you that, yes, I am in fact a human. That is true. Well, everyone, that is the basics of variables. It is a container for a value, and they behave as the value that they contain. There are 4 basic data types: strings, which store a series of characters; ints, which store a whole integer; floats, which are floating point numbers; a numeric value with a decimal; and Booleans, which only store true or false, and they're very useful with if statements. So that is it for variables. If you would like a copy of all this code, I will copy and paste all of this to the comment section down below. But yeah, that is how variables work in Python. Hey people, what's going on? It's Bro, hope you're doing well, and in this video I'm going to explain multiple assignment in Python, so sit back, relax, and enjoy the show. Well then, since you clicked on this video, I should probably explain what multiple assignment is. Now, multiple assignment allows us to assign multiple variables at the same time using one line of code. Here's an example of us using standard assignment. Let's say we have a variable name, and I will set this to a value of my name, but you can use your name for this example. Let's say age equals 21, and how about a variable called attractive? I think I'm gonna set this to true. Okay, so we have a bunch of variables, and then we can print the value of these variables with some print statements. So let's print name, age, and attractive. So we have name, age, attractive. And as you would expect, this prints bro, 21, and true. Now, another way in which we could write the same code is to use multiple assignment, and this allows us to assign multiple variables at the same time using one line of code. So I'm going to turn all of these lines into comments, and this time we will only use one line of code. But to do this, we're going to list all of our variables separated with a comma. So that would be name, comma, age, comma, attractive. And we will set them equal to those values, but in the same order, separated by commas. So that would be bro, comma, 21, comma, true. And this would do the same thing, only using one line of code. Here's another example. Let's say we have 4 variables: SpongeBob, Patrick, Sandy, and Squidward. And let's pretend that they're all around maybe 30 years old. At least it seems like they're around 30 years old, but I could be wrong. I'm not too familiar with SpongeBob lore. So let's set them all equal to 30. Now, we could write this using 4 lines of code, or we could use multiple assignment to write the same thing using 1 line of code. So if all of these variables are all equal to the same value, there's a little bit of different syntax here. So let's begin with the first variable of SpongeBob equals Patrick equals Sandy equals Squidward. Then we're going to set them all equal to 30. And this should work just fine using only one line of code. Well, everybody, that's pretty much it for multiple assignment. It allows us to assign multiple variables at the same time using one line of code. I will post all of this code in the comments section down below. And well, yeah, that's how multiple assignment works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to demonstrate some useful string methods in Python. So sit back, relax, and enjoy the show. Alright, let's do this. In this video, I'm going to be explaining and demonstrating a few useful methods available to us for strings. Now let's create a variable called name for this example, and you can use your own name if you want. So we now have a variable called name. And for my first example, let's print the length of our name variable. So to do that, we can surround our name variable with the length method, and this will print and return how long the length of our string is. And for me, the length of my name variable is 3 for 3 characters. If I were to increase the size of my name, well then that's going to change to 8. So that is the length method, and I'm just going to turn this line into a comment, and let's move on. So next we have the find method. I just copy and pasted print name so I can reuse it. Name dot, and actually if you have IntelliSense set up, if you add dot after your variable, you'll get a suggestion, well, a few suggestions of different methods and other features that you have access to. So let's find, which is, screw this, I'll just type find. Find, then we can find the first index of where this character is. Let's say I would like to find where capital B is. Well, that is at index 0 because computers always start with 0. So this first character would be 0, then R would be 1, and then O would be 2 for this example. Alright, so that is how to find a character within a string. Moving on. So let's capitalize our name, and I should probably make this lowercase. So name dot capitalize, and this will make my name capitalized. But if there's any spaces and then additional words, it's not going to capitalize that, only the first letter in your string. Next, we have upper. This will make your string all uppercase. Name, upper. And now it is uppercase. Guess what's next? Lower. Name, dot, lower. And I should probably make this capital again. And everything is lowercase. We're making some good progress today. Next, we have isDigit. This will return true or false, depending on if our string is a digit, which it's not, so this will print false. If I changed my string to a bunch of numbers like 1, 2, 3, then this will return true. Let's change that back and move on. Next we have isAlpha. Are these alphabetical characters? Oh, make sure you add the parentheses afterwards, my bad. False, because we added a space within here. Now it's true. So you can use isAlpha to check to see if your string contains only letters, alphabetical letters. Next we have count. We can count how many characters are within our string. I would like to count how many O's are in here, and this should return 2. That's right. Okay, we're almost at the end. We can replace characters within our string. So we use the replace method, and we pass in 2 arguments, the character we would like to replace and the character we would like to replace our character with. I would like to change all O's to A's, and now my name is Brakad. Oh, you guys are gonna like this next one. This isn't technically a method, but it's a really neat feature. So one thing that we can do that's available to us with Python is that we can display a string multiple times by multiplying that string by a given number. So let's say I would like to display my name 3 times. I can just take my string variable, then add times 3, and this will print my name 3 times. Bro. Like I said, not technically a method, but it's a useful feature that you might be interested in that's related. Alright everybody, so that is a few useful methods available to us for strings. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, those are a few useful methods available to us for strings. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about typecasting in Python, so sit back, relax, and enjoy the show. Alright, welcome back everybody. I have a super quick video for you guys today on the subject of typecasting. Now, typecasting is the ability to convert the data type of a value to another data type. Here's an example that I've written already. I'm just going to paste it. I have 3 variables for this example, x, y, and z. X contains 1, this is a whole integer, int for short. Y contains 2.0, this is a floating point number, float for short. You can tell it's a float because it ends with a decimal portion. And z contains a string of 3. A string is a series of characters, and you can tell it's a string because it's surrounded with a set of quotes. And remember, with strings, we cannot normally perform math on strings. So I have 3 print statements for x, y, and z. And as you would expect, they contain the values of 1, 2.0, and 3. Now let's begin by converting both y and z to the integer data type via typecasting. In order to perform typecasting on a value or variable, type that value or variable and surround this with a set of parentheses. Whoops, I missed. And then precede this with the data type you'd like to convert this value or variable to. I would like to convert y to an integer, and then you can use this for whatever you need. So I'm going to replace y within my print statement with y after we typecast it as an integer, and this will display 1, 2, not 2.0, it's the whole integer of 2, and then 3. So this is not a permanent change. If you need to make this as a permanent change to y, you'd have to reassign it. So let's say y equals y, and then we're going to typecast y. So let's surround this with a set of parentheses and precede this with the data type we'd like to convert y to. So now y is a whole integer, and then we will print y without the typecast this time. And our result is 1, 2, 3. Now z is storing a string, and with strings we cannot normally perform any math on strings. For example, within my print statement, I will state z times 3. You would think that the result would be 9, right? Well, you're wrong. It's going to print 3 times. If you need to convert a string to a int or a float, you would just have to typecast it. So this time, let's typecast z as an integer, z int, and we will typecast z as an integer. So then if we have z times 3, the result is now 9 instead of 333. So that's the basic formula for typecasting. Now let's convert these to floating point numbers, but let's include x as well because x is feeling left out. So let's convert x to a floating point number. So float parentheses, and we will surround this with x and display x. And actually, let's convert y and z to floats as well because why not? So the results are now 1.0, 2.0, and 9.0. Remember that we multiplied z times 3. And then if we need to convert these values to a string, we would use the string cast. So the results now are 1, 2.0, and 333. Now you might be thinking to yourself, when would you need to convert an integer or a float to a string? Here's a situation. Let's say within our print statements, we need to print these variables along with another string. So within our print statement, let's say x is plus x. We would like to display these together. And let me copy this and do the same thing for y. We'll say y is plus y. You cannot normally display a string along with an integer or a float because we're using some string concatenation. So this will result in a compilation error. Can only concatenate string, not int to string. So that's a situation in which you might need to use typecasting to convert an integer or float to a string. So let's display x and y as strings via typecasting. So we'll surround x and y with a set of parentheses and precede this with the data type we'd like to convert these values to. We would like to convert x and y to both strings, and now this will compile and run just fine. Well, everybody, that's the basics of typecasting. If you would like a copy of all my code, I will post everything in the comments down below. If you found this video helpful, don't be afraid to help me out by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's Bro. Hope you're doing well, and in this video I'm going to teach you guys how we can accept some user input in Python, so sit back, relax, and enjoy the show. Ladies and gentlemen, this is where the fun begins. In this video I'm going to explain how we can accept some user input in Python, and we do so by using the input function, and then we type in our input to the console window, but it would probably be good practice to let the user know what we want them to type in exactly. So let's ask for somebody's name. Within quotes, inside the input function, I'm going to type, "What is your name?" And now our program will wait for us to enter in some user input. So you can use your own name for this example. I'm going to type bro. Now to submit some user input, you just type or press enter. Now you can see that my process finished with execode 0. That means the program is done running. So we should probably do something with this value. We can actually assign it to a variable so we can use it elsewhere in our program. So to do so, we precede input with a variable like NameWorks, name equals input. And when we accept some user input, we will assign it to this variable that we called name. And now we can do something with it. So let's print a message involving our name variable that we have. So how about hello plus name? Now when I run this program, we can accept some user input and then do something with that input, such as display a message that says, "Hello, bro." And then you can type in whatever you want for your name. Let's say I'm Dude. What is your name? Dude. Hello, Dude. Now this next part is very important. When we accept user input, it is always of the string data type, a series of characters. What if we need to accept a number? Well, you can, but you can't normally perform any math on it because it's of the string data type. We would need to cast it as either of the integer data type or of the float data type. So here's an example of why we can't perform any math on a string. Let's say we have a variable called age. Age equals input, and let's ask how old somebody is. How old are you? Now, I will add 1 to somebody's age. Let's pretend it's their birthday. Age equals age plus 1. This will add 1 to their age. Now, let's try and run this. What is your name? Bro. How old are you? Let's say that I'm 21. Okay, we ran into an error, a type error. Can only concatenate string to string. With what I mentioned previously, we cannot normally use strings for any sort of mathematical equation or operation. We'll want to cast it to the integer or the float data type. So let's cast our user input to the integer data type, and we will surround our user input with a cast. Surround your input with a set of parentheses and precede this with int. And now we can use this user input in a mathematical operation. So let's try it, even though this won't display age yet. So what is your name? Bro, 21. And our program finished with an execode of 0. There were no problems. Now let's attempt to display this age. So I will print you are plus age plus years old. We're doing some string concatenation here. What is your name? Bro, how old are you? 21. Alright, we ran into a type error again. Can only concatenate string to string. You cannot normally display a variable of the integer data type along with strings because we're doing string concatenation. We're adding strings together. We would need to convert this variable back to the string data type so we can cast it. We'll surround our age variable with a cast. Now this is what's going to happen. We will accept some user input, it will be of the string data type, and then we will immediately cast it to be of the integer data type so that we can treat it as a number instead of a character. And then if we need to display this age, we will need to convert it back to a string so that we can use some string concatenation and display all of these strings together. And now let's try this theory. So what is your name? Bro. How old are you? Let's say I'm 21. Hello, bro. You are 22 years old. Here's a situation. What if we enter a number that contains a decimal portion? So let's try this again. Let's say I'm 21.5 years old. Well, now we ran into a different issue, a value error. Invalid literal for int with base 10. That means if we cast a string as an integer, it can only be a whole number, a portion that does not contain a decimal. And that is where the float data type would come in. It is a data type that can contain a decimal portion. For this example, let's create a third variable called height, and we will ask for somebody's height. Input, we'll create a prompt that says, how tall are you? And we will cast this to be of the float data type so that our string, our user input, can contain a decimal portion, and then we can treat it as a number instead of a series of characters. And I think I will delete this line, we won't really need it anymore. And then let's print their height along with a message. You are plus, then height, but we need to cast this back to being a string. So we'll surround our height with a cast, plus, let's say cm tall. All right, let's test this. What is your name? Bro. How old are you? Let's say I'm 21. How tall are you? Let's pretend that I'm 250.5 centimeters tall. I'm adding the 0.5 just to test to see if this will accept a floating point number. Hello, bro. You are 21 years old. You are 250.5 centimeters tall. Not really. All right, everybody. So that is the basics of user input in Python. Normally with user input, it will give you a value of the string data type. If you need to use that value for any sort of math, you'll probably need to cast it to be of the integer or the float data type. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to accept user input in Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video I'm going to demonstrate a few useful functions related to numbers in Python, so sit back, relax, and enjoy the show. Okay, let's begin. In this video I'm going to be demonstrating a bunch of useful functions related to numbers, and a bunch of these functions are located within the math module. Now let's create a variable for this example. Let's say pi equals 3.14. Just the first few digits of pi is fine for this example. And now here's a bunch of useful functions that you guys would probably be interested in. The first is round. Round is a built-in function, and all we do is type round, then add a set of parentheses, and then we can pass in a value or a variable as an argument, and the round function will round that number for us. So pi rounded to the nearest whole integer is, you guessed it, 3. Now, we can round a number up by using the ceil function of the math class. Ceil, short for ceiling. So let's print our result, and in order to access this function within the math module, we would type the name of the module, dot, and here's a bunch of functions that we have access to. So we are looking for ceil, and it's actually at the top here for me, and ceil will round a number up to the nearest whole integer. So pi rounded up is 4. Then on the flip side, we can round a number down by using floor, and that is also located within the math module. So let's type math.floor, and pi rounded down would be 3. Up next, I have the absolute value function, but it's ABS for short. ABS will give you the absolute value of a number. So the absolute value of pi, actually let's make this negative 3.14. The absolute value will tell you how far a number is away from 0. So if you pass in a negative number, it will give you a positive number. So that is ABS, short for absolute value. Next we have the pow function. Pow will raise a base number to a power. Let's raise pi to the power of 2. So we pass in 2 arguments, a base and an exponent. Pi to the power of 2 is 9.8 and some change. So that is the pow function. Next we have square root. So this is located within the math module. We'll type math.sqrt, short for square root. And the square root of pi is, let's find out. Oh, I guess we can't pass in pi. Let's round a different number, like 420. Oh, I guess that's because I made pi negative. Okay, so the square root of 420 is 20.4 and some change. So that is the square root function. All right, we have two left. We have the max function. The max function will find the largest of a varying amount of values. So let's create three variables for this example. Let's say x equals 1, y equals 2, and z equals 3. We can use the max function to find the largest of these values. So within a print statement, let's use the max function and pass in all of the different values or variables that you would like to compare. So I would like to find the largest value between x, y, and z. And the result in this example is 3. Now the min function will find the lowest. So min, and then pass in your values or variables. So I would like to find the minimum value between x, y, and z. And in this case, it is 1. Well, everybody, those are a few useful functions that you guys might be interested in. If you guys would like a copy of this code, I will post this in the comments section down below. But yeah, those are a few useful functions related to numbers in Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to explain string slicing in Python. So sit back, relax, and enjoy the show. Alright then, let's talk about slicing. Slicing can be used to create a substring by extracting elements from another string. The same principle can also be applied to different collections as well, but in this video we're going to be focusing on slicing strings. Now to slice a string, we can either use the indexing operator, which is a set of square brackets, or by use of the slice function to create a slice object. This is a little more complex. We'll discuss the slice function near the end of this video. So, with slicing, there are three optional arguments, three fields that we can fill in depending on where and how we want to slice our string. A starting index, a stopping index, and a step. Let's begin with the starting index. Now, for this example, let's say we have a string variable called name, and this will store a value of whatever your own full name is. Yes, I legally changed my name to Brocode. You can use your own name for this if you want. So what I would like to do is to create a substring based off a sliced portion of my full name. So what I would like to do is create a substring based off of just the first part of my name, just bro. So let's begin by creating a substring. Maybe I'll call this first name equals. Now to slice a string, type in a string or the name of a variable that contains your string and follow this with the indexing operator. And like I said, we'll discuss the slice function a little bit later. So we need a starting index and a stopping index, but we'll begin with the starting index. Where do we want to begin our slice? So computers, they always start with 0. So the first character in your string will have an index of 0. I would like my slice to begin at index 0. So I'll list that for the starting position, the starting index. So let's test this just to be sure it works. I'll just print first name. And let's see if this prints capital B, which it does. So following that same pattern, the next character within my string would have an index of 1. That would be R. Then the next index 2 would be O, and 3 should be an empty space. All right, so that is the starting index within string slicing. If we would like to slice an entire portion of our string, not just one letter, we need a stopping index as well. And both of these fields are separated with a colon. So let's say I would like to slice the first 3 characters of my string. So this would have an index of 0, 1, 2. And this isn't going to work as you would imagine, and I'll explain why. So you would think that indexes 0 through 2 would give us 3 letters, right? But it only gives us 2. So this first index is inclusive. The stopping index is exclusive. So if I want the first 3 characters, the first 3 letters in the string, I would need the starting index to be 0 and the stopping index to be 3. And now this should print my first name and not anything else. There is a shorthand way of writing this too. So if you were to leave this first index blank for start, well, Python is going to assume that this is 0, the beginning of your string. So this would be no different than what we had previously, just having :3. Now, let's try and create a separate substring for a last name. So, last name. Name. Now we need a starting index and a stopping index. So we need the starting index at least. So this would be 0, 1, 2, 3, 4. 4, colon, and where do we want this to stop? 0, 1, 2, 3, 4, 5, 6, 7. And remember that this is exclusive, so we're going to place 8 here. And now I would like to display last name, and this should just display code. And a shortcut is that if you were to leave stop blank, but you still have that colon, this is a shorthand way of writing, I would like every character starting at index 4 and everything after until the end. So there would be no change to this as well. You can write it either way. Okay, so we still have to discuss step. Step is an optional field that we can set a value to. So step is how much we're increasing our index by between starting and stopping. So it is entirely possible to create a substring that will count only every second character after the first. Normally step is 1 by default, but if we were to set that to 2, we're going to count only every second character. So let's try this. Maybe I'll create a new variable called funky name because I really don't know what else to call this for this example. Let's say funky name equals name, and I'm going to count only every second character, including the first. So the indexes would be 0, colon, 8 for my example, but if you're using your own name, that's probably going to be something different. So the default for step is 1, and if I were to display funky name as it is currently, this will just display my full name. But if we set step to 2, this will only display every second character, including the first. So funky name is now, for me at least, BOCD. Now if step was 3, this will print only every third character, including the first, where it's B space D. A shorthand way of writing this is that you could leave start and stop empty, but the important thing is to have these 2 colons. Python is going to assume that if you leave your starting index empty, you're referring to index 0, the beginning. If your second index, your stopping index, is empty, Python will assume this will be the very end of your string. So just having 2 colons and then step 3 would be no different than what we had previously. For this next part, I'm going to explain how we can reverse a string in Python. So let's create a new substring variable called reversed name equals name. I would like to use the entire string, so I can just use 2 colons. Python will fill in the rest. So for the step, this is going to be -1. It's kind of like we're counting backwards, and we're going to create a new substring based off my name, but in reverse. So if I were to print my reversed name, this is now edoc.orb. I think that's how you pronounce it. So that's how to reverse a string in Python using slicing. Now let's move on to part 2 of this video. I'm going to be explaining the slice function, and we can use the slice function to create a slice object, which is actually reusable, so that's somewhat convenient. Let's take a different scenario this time. Let's say we have a website URL. Website equals http:// google.com, but use whatever website you want. What I would like to do for this program is remove and create a substring based off the website name and not anything else. I would like to exclude the HTTP portion as well as the .com portion of this website URL. So let's break it down step by step. Our first step is to create a slice object, so I will name the slice object as slice. Slice equals, and I will invoke the slice function. So within the parentheses of the slice function, we can add up to 3 values: a start, a stop, and a step. Exactly the same as what we did with indexing. However, with the slice function, we separate each of these values with a comma instead of a colon, but it works the same way. So we would like our substring to begin where the name of the website begins. So we would like our start to be 0, 1, 2, 3, 4, 5, 6, 7. So I will pass in 7 for where my substring will begin. And now each value within the slice function will be separated with a comma instead of a colon, like what we did with the indexing operator. Now for the stop index, that's going to be a little bit tricky, and let me explain why. One issue that we're going to run into is that not all website names are consistent with their length. They can really vary. So it is not possible for us to use the same stopping index for each of these website URLs. So one way in which we can account for that is to use what is called a negative index. Each character within a string has a positive index as well as a negative index, and a negative index works almost exactly the same way, except the character most on the right begins with a negative index of -1, and the character on the left of that would be -2, -3, and -4. It's as if you're counting backwards. So with indexing, we can use some combination of positive and negative indexing. So I would like my substring to end where this dot is. So this would have a index of -1, -2, -3, -4. And remember that this is exclusive. So I would like my slice to begin at index 7 and a negative index of 4 for the stopping position. So that will give me just the website name and remove the HTTP portion as well as the .com portion of my website URL. And now we have a slice object and we can reuse this. So to apply your slice object, type in the name of your string, index operator, and place your slice right within here. And let's print this. So print our website and apply the slice to it. And now this should give us just the website name. And now let's test this with maybe another website. I'll rename this as website 1 and let's create website 2. And let's try a different website name for good measure. So let's try Wikipedia. So we can reuse our slice object and we will apply our slice to website 2 this time. And this should remove the URL portions, HTTP as well as .com. All right, everybody, so that is slicing strings in Python. You can either use the indexing operator or the slice function to create a slice object. If you would like a copy of all this code, I will post all of this in the comment section down below. But yeah, that is how string slicing works in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to explain if statements, else if statements, and else statements in Python. So sit back, relax, and enjoy the show. All right, people, let's talk about if statements. An if statement is a block of code that will execute only if its condition is true. It's a very basic form of decision-making with programming. For this example, let's create a prompt where we will ask a user for their age, and depending on what their age is, we will print a response. So let's say age equals input, and then we will add a prompt. How old are you? Now this will return a string, so we should probably cast this as an integer data type. So we now have a variable called age where we will accept some user input. Let's check somebody's age with a variety of if statements. So let's check to see if somebody's age is greater than or equal to 18. So to create an if statement, type if, and then some sort of condition. If age is greater than or equal to 18, to finish this if statement, add a colon at the end. Now pay attention to this. If I move down to the next line, you'll notice that my cursor is now indented. Any indented code underneath an if statement is the block of code for that if statement. So if this condition is true, we will execute some block of code. If it's false, we'll skip over it. So if somebody's age is greater than or equal to 18, let's print you are an adult. And let's try this program. How old are you? Let's say I'm 21. So my condition when we get to the if statement is going to check to see if this condition is true. If it is true, we're going to execute this block of code. If it's not, we skip over it. So how old are you? Let's say I'm 21. I'm going to hit enter. And my if statement is true, so we execute this block of code which prints, you are an adult. So what if this condition is false? Let's say I'm 12. Well, then we're just going to skip over this block of code and continue on with the rest of the program. If you would like your program to take some other course of action, if this condition is false, we can add an else statement. So after the if statement, add else. Make sure you get the indentation right. You don't want this within the block of code for the if statement. So if this condition is false, we can take some other course of action. So if somebody's age is less than 18, let's print you are a child. So let's try this again. I'm going to enter that I am 12 years old. Not really, but let's just pretend I am. So this will now print you are a child. If this condition is false, perform this block of code for the else statement. So with if statements, we can check more than one condition before reaching the else statement by using an else if statement, and we add that after an if statement. So it's shortened to ELIF for else if. So let's check to see if somebody's age is less than 0 for some reason. So let's print, you haven't been born yet. So with if statements, we start at the top. We first check the if statement. If this is false, we move down to the next statement to check. Then we check our else if statement. If this is also false, then we resort to the else statement. The else statement is sort of like a last resort. If all conditions evaluate to be false, then we execute the else statement. So let's try this. How old are you? Let's say I'm -1 years old. You haven't been born yet. So with if statements, we always begin with an if statement and we check that condition. If that condition evaluates to be false, then we will skip this block of code and move down to the else if statement. If there is one, it's optional. If this condition is also false, then we will use our else statement as a last resort if there is one. If there is no else statement, then we just skip over all of this then and continue on with the rest of the program. So you can add more than one else if statement. So let's check something else. Let's check to see else if age is equal to 100. So if you need to check to see if a value is equal to a particular value, make sure you use double equal signs. This is the comparison operator for equality. If you use just one equal sign, that's the assignment operator, and Python thinks you're attempting to set age equal to 100. So if you want to check to see if age is equal to 100, then use double equals. So let's check to see if somebody's age is equal to 100. So let's print, you are a century old. Now pay attention to this if I were to run this program. How old are you? Let's say I'm 100. So this is printing, you are an adult. That's because we first check our if statement, and well, we're 100 years old, and 100 is greater than or equal to 18. So we print this block of code, we execute this block of code, and then we skip everything else, even though age is equal to 100 within our else if statement. So the order of your if statements does matter. So let's change this around. Let's add this to the very beginning. And this will be our if statement, and we will set age is greater than or equal to 18 to be an else if statement. So we're first going to check to see if age is equal to 100. If not, we will check to see if age is greater than or equal to 18. And we just follow that order. So let's try this again. How old are you? I am 100 years old. You are a century old. So we first check our if statement. If this condition is true, we will execute this block of code. If it's false, we just go down the order till we reach our else statement. Well, everybody, that is the basics of if statements. We have if statements, else if statements, and else statements. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that is how if statements work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain logical operators in Python. So sit back, relax, and enjoy the show. Alright, everybody, let's talk about logical operators. These are used to check if two or more conditional statements are true. So we'll be discussing the AND as well as the OR logical operators. There's also a third one called NOT, but that works a little bit different, and I'll explain why. So let's create a program to demonstrate this. Let's create a program where we will ask somebody for the temperature outside. And then depending on the temperature, if it falls within a certain range, we will print a message. So we'll need to use AND as well as OR logical operators to do this. So here I have a prompt, temp for temperature equals input, what is the temperature outside? So I'm going to cast this as an integer data type. So what if we want to check to see if our temperature is within a certain range? We can use the AND logical operator to check two or more conditional statements. This is how we might do that. Let's check if temp is greater than or equal to 0 degrees Celsius. And we can check another condition too. If temp is less than or equal to 30 degrees Celsius. So we need to add a colon at the end to finish this if statement. And let me just fix some of the spacing. Okay, so with the AND logical operator, in order for this entire condition to be true, both conditions must be true. This needs to be true, and this needs to be true. So if our temperature is equal to or above 0, as well as being less than or equal to 30, that means our temperature falls within a certain range. So let's print a message such as, the temperature is good today. Print, go outside. All right, let's try it. So what is the temperature outside? Let's say it's 20 degrees Celsius. Well, the temperature is good today. Go outside. This condition is true. 20 is greater than or equal to 0, and temperature is less than or equal to 30. Let's try a different temperature, like negative 20 degrees Celsius, so it's really freaking cold outside right now. As you can see, nothing happened because our first condition was false. Our temperature is not greater than or equal to 0, but our temperature is less than or equal to 30, so our second condition is true, but our first condition was false. And in order for this entire statement to be true, since we're using the AND logical operator, both conditions must be true in order for this statement to be true. Now let's discuss the OR logical operator. We can check to see if our temperature is below or above a certain range. So let's write else if temp is less than 0 or temp is greater than 30. So that means it's going to be either very cold outside or very hot outside. So let's print a message. The temperature is bad today. Print, stay inside. All right, let's try this again. What is the temperature outside? It is negative 20 degrees outside. The temperature is bad today. Stay inside. So with the OR logical operator, as long as one of these conditions is true, then the entire statement is true. It doesn't matter if one of them is false. As long as one of them is true, then the entire statement is true. Last but not least, we have the NOT logical operator. This works a little bit different from the AND as well as the OR logical operator because we can check one or more conditional statements instead of two or more conditional statements. So what the NOT logical operator will do is that it'll take a conditional statement. If it's true, it's going to flip it to false. If it's normally false, it's going to flip it to true. So for this example, we have another way in which we could write this, although it's a little more complex. So if our statement is true, what we can do is that we can flip it to false using the NOT logical operator. If it's normally false, we can change it to true. So what we'll do is surround one or more conditional statements with a set of parentheses and precede everything within the parentheses with the NOT logical operator. So if the statement is normally true, it's going to become false using the NOT logical operator. If it's normally false, it's going to be true then. Let's do the same with the else if statement. So surround one or more conditional statements with the NOT logical operator. So now these roles are going to be kind of reversed. So let's try this again. What is the temperature outside? It is negative 20 degrees outside. The temperature is good today. Go outside. So what we should probably do is kind of reverse these roles. So I'm just going to swap everything within these if statements with each other. And now this should work the same as it did before, but we just wrote it a little bit different. What is the temperature outside? It is 15 degrees outside, 15 degrees Celsius. The temperature is good today. Go outside. So with the NOT logical operator, you can surround one or more conditional statements with the NOT logical operator. And what this will do is flip it from being false to true or from true to false. Well, everybody, that's the basics of logical operators in Python. If you would like a copy of all this code, I will post this in the comments down below. But yeah, that's the basics of logical operators in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain while loops in Python, so sit back, relax, and enjoy the show. So, while loops. A while loop is a statement that will execute its block of code as long as its condition remains true. Later on in this video, for this example, we're going to create a program where we will prompt a user to enter their name. If they attempt to skip that prompt, then we will continually ask the user to enter their name, and they can't continue on with the rest of the program until they do so. The key thing to keep in mind with while loops is that you'll want some way to eventually escape the while loop. If you don't have any way to escape the while loop, that's referred to as an infinite loop. So let's create an example of an infinite loop because it's fun. So to create a while loop, type while and then some sort of condition. So for our condition, let's say while 1 is equal to 1. So this will always be true. Now, what do we want to do when we execute this block of code? Let's print something. Print help. I'm stuck in a loop. All right, so let's try this. While 1 is equal to 1, print this statement. And we will just continue on and on within this while loop because we have no way to escape this while loop. So now let's use this concept and write a program where we will prompt a user to type in their name. If they don't type in anything, then we will continue to prompt them to type in at least something. So let's say name is equal to, and then to just keep this blank, we'll just set this to a set of quotes. And then let's write a while loop here. While name, and let's check the length of name. If the length of our name is equal to 0, then we will ask the user to type in their name. Name equals input, enter your name. So then once we escape the while loop, let's print something. Print hello plus name. Whoops. Hello plus name. All right, so when I run this, we are giving the user a way to escape the while loop. They have to type in something for their name. As long as the length of my name is equal to 0, keep on printing this prompt, enter your name. So I'm just going to hit enter a bunch of times. Enter your name, no. Enter your name, no. Enter your name, no. So we are stuck within this loop until we enter something for our name. So this time, let me type in a name, then hit enter. So therefore, our condition is now false. The length of my name is now 1, 2, 3. So 3 is not equal to 0, therefore our while statement, our while loop, is false, and we continue on with the rest of the program. There are a few variations in which you could write the same program, so let's write this a different way. What we could do is say name is equal to none, while not name. And this will pretty much do the same thing, it's just another way of writing this. Well, everybody, that's the basics of while loops. A while loop is a statement that will execute its block of code as long as its condition remains true. For our example, we asked the user to type in their name. If they were to leave it empty or blank, we would keep on asking the user to type in their name. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that's the basics of while loops in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain for loops in Python, and at the end of this video we're going to create a countdown timer, so sit back, relax, and enjoy the show. Alright guys and gals, let's talk about for loops. A for loop is a statement that will execute its block of code a limited amount of times. It's similar, but different from a while loop because a while loop could iterate an unlimited or infinite amount of times depending on the condition. A for loop will only iterate a limited amount of times, and before we start executing its block of code, we already know how many times we're going to repeat this block of code. So for this example, let's create a for loop that will simply count up to 10, and then we'll create a few more sophisticated examples. So to create a for loop that will count up to 10, this is what we'll type. For, and then we need some sort of counter. People usually either write index or they shorten it to just I for index. For I in, and we can set a range. Range 10. So we will execute this for loop 10 times. And to finish this for loop, just add a colon at the end. So the next line or lines will be indented. So that's the block of code for the for loop. What do we want to do during each iteration? Let's just print what I is. And let's take a look to see what would happen. So we executed this for loop 10 times, except with computers always start with 0. So when we said for I in range 10, we're counting numbers 0 through 9. So it's as if this number is exclusive. So there's two ways we can change this. We could say range 10 plus 1, or what I would do is say print I plus 1. So this will give us numbers 1 through 10. So that's a for loop. It will execute a limited amount of times. This time, let's count a range between two numbers, not necessarily 0 to 10, but something else. So let's say for I in range, maybe the numbers 50 through 100. So within my range function, I will pass in two numbers. The first number will be the starting point, and the second number is the ending point. This first number is inclusive, and the second number is exclusive. So let's print this. Print whatever I is. So this will count 50 through 99 actually. If you wanted to include this last number since it's exclusive, what we could do is just add 1 to the end. So this would give us 50 through 100, except that this will iterate 51 times since we're counting 50. So you just have to pay attention to your range and the numbers that it's counting. Now, one thing that you could do with the range function is that you can add a third argument, and this will function as the step, how much you want to count up or down by. So this time, let's count up by 2. So I'll add comma 2. We're passing in a third argument this time. So this program will now count up by 2, starting at 50 and go all the way to 100. A benefit of for loops is that we can iterate through anything that is considered iterable. This could include a string, the letters in a string, or any sort of collection. So this time, let's create a for loop that will iterate once through each letter in maybe a name. So for I in, and let's type a name here. Type in whatever your first name and last name is. And then we will print whatever I is. For I in whatever your name is, print each letter in the string. So when I run this, each letter within my name will be printed to a new line. All right, people, for my last trick, we're going to create a program where we will simulate a countdown starting at 10 and count down to 0. And then maybe once we reach 0, we can print something such as Happy New Year. So to create this program, we'll need an import. So at the top, we're going to import the time module because we'll be waiting 1 second after each iteration of this for loop. So to create this program, let's say for, you could say I, but you can really write anything here. And to demonstrate that, let's say 4 seconds. 4 seconds in range. So the starting point is going to be 10, the ending point will be 0, and we'll add a step. What do we want to count up or down by? Let's set this to -1, so this will be a countdown starting at 10 and ending at 0. So after each iteration, let's print whatever I is, or in this case, seconds. And then we can sleep, have our thread sleep for a number of seconds too. So after we print seconds, type time.sleep and pass in how long you want to sleep for. I would like to sleep for 1 second. And then at the end, let's print Happy New Year. Make sure this isn't within the for loop. Print Happy New Year. And well, that's it. Let's test this. So we'll begin at 10 and count down to 0, and you can see that my thread that is running this program is sleeping for 1 second after each iteration of this for loop. Then once we reach 0, it will display Happy New Year. Well, everybody, that's the basics of for loops. A for loop is a statement that will execute its block of code a limited amount of times. It's different from a while loop because a while loop could execute an infinite or unlimited amount of times. With for loops, they execute limited amounts of times, and before we enter the for loop, we already know how many times we're going to iterate this for loop. If you'd like a copy of all this code, I will post this in the comments down below. But yeah, that's how for loops work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain nested loops in Python. So sit back, relax, and enjoy the show. Hey all you people, let's talk about nested loops. A nested loop is a general concept of having one loop inside of another loop, and that's really it. It doesn't matter if it's a for loop or a while loop. So the inner loop will finish all of its iterations before we finish one iteration of the outer loop. And to best demonstrate this, we're going to create a program where we will draw a rectangle made out of a certain symbol that we choose. We need to set a width and a height. And to best do this, we'll need to use a nested loop. We'll create a few prompts, one for rows, columns, and a symbol that we want to make a rectangle of. So let's begin with rows. Rows equals input, how many rows? And we'll need to cast this as an integer data type because we're working with numbers. Okay, let's do the same thing for columns. So replace rows with columns for this next line. Input, how many columns? And we'll create a symbol variable. Symbol equals input, and this we don't have to cast. Enter a symbol to use. Now it's time for the nested loops. We're going to create an outer for loop as well as an inner for loop. The outer for loop will be in charge of the rows. The inner for loop will be in charge of the columns. So let's begin by creating our outer loop. So we'll write for I in range rows. We would like our outer for loop to iterate as many times as we have rows. And we're going to create an inner for loop that will iterate as many times as we have columns. So within the block of code for the outer for loop, we're going to create another for loop. This time it'll be for, and a common convention for inner loops is to write j as an index because j comes after I guess. So for j in range columns. So our inner for loop will iterate for as many times as we have columns. All we'll do within the inner for loop is print our symbol that we have, except we'll have one issue. Using a print statement, after we use the print statement, we will enter a new line character in and move down to the next line. We can actually prevent that by adding comma end equals quotes. So after using a print statement, this will prevent our cursor from moving down to the next line. So pay attention to the indentation too. So there's kind of two levels of indentation. We're currently within the inner for loop. So that's pretty much it for the inner for loop. Now we're going to print a new line once we exit the inner for loop. And you can see that the indentation is on this line right here. We're within the outer for loop now. And that's pretty much it. So let's try this program. How many rows? Let's say 5 rows. How many columns? Perhaps 6. What symbol do we want to use? Let's say the $sign. And let's try it. There we go. There's our rectangle. So we have, let's see, 6 columns, 1, 2, 3, 4, 5, 6, and 5 rows, 1, 2, 3, 4, 5. In summary, a nested loop is really just this concept of having one loop inside of another loop. It doesn't matter if it's a while loop or a for loop. It's really situational. The inner loop will finish all of its iterations before finishing one iteration of the outer loop. So what we did to demonstrate that is that we had the outer loop in charge of the rows, and an inner loop in charge of the columns for our rectangle program. So if you would like a copy of this program, I will post this in the comment section down below. But yeah, that's the basics of nested loops in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain loop control statements in Python, so sit back, relax, and enjoy the show. Alright, ladies and gentlemen, let's talk about loop control statements. These are used to change a loop's execution from its normal sequence. And there are 3 we're going to discuss: break, continue, and pass. Let's begin with break. Break is used to terminate the loop entirely. Now here's a good example of where a break would be useful. Let's say while true, we're going to continually ask for somebody's name. If they don't type in anything, then we'll continue the while loop over and over again. So let's say name equals input, enter your name. Now, if name does not equal a set of quotes, that means they don't type in anything, then we will break out of this while loop. And let's test it. Enter your name. Nah, I don't think so. I'm too lazy to enter my name. Alright, I can see that I'm not going to escape this while loop, so I'm going to type in my name because I give up and hit enter. Therefore, I will break and exit out of this while loop. So a break is used to terminate the loop entirely when it's encountered. Next, we have continue. Continue skips to the next iteration of the loop. Now let's say we have a phone number, phone underscore number, and I will set this equal to, let's say, a random phone number, including dashes, 123-456-7890. What I would like to do is to display this number within the console window without these dashes. This is how to do that using a continue control statement. For I in phone number. So for each character within our string of phone number, what we'll do is check to see if we encounter a dash character. If I is our index, is equal to a dash, then we want to continue and skip over this iteration of the loop. So continue. Then I would like to print whatever our indexes, whatever character we're working on. So if I were to run this as it is, it's going to print each digit on a new line. So with print statements, they will add a new line character to the end of your string. And you can actually change that by adding to the end, comma, end equals, and then a set of quotes. So this will print my phone number without any dashes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So that's a use of the continue control statement. It skips to the next iteration of the loop. Last but not least, we have pass. Pass does nothing. It acts as a placeholder. Let's say that I would like to print the numbers 1 through 20 using a for loop. For I in range 1 through 21. And remember that the second digit is exclusive. So this will iterate once through the digits of 1 through 20. Let's pretend that I'm highly superstitious and I don't want to print the number 13 because 13 is considered an unlucky number. If I is equal to 13, what we'll do is pass, and pass acts as a placeholder and it won't do anything. Else, print I. That's 1. I. There we go. This will print the numbers 1 through 20 and skip 13 because we used the pass control statement, which does nothing. It acts as a placeholder. So everybody, those are loop control statements. They change a loop's execution from its normal sequence. We have break, continue, and pass. So if you would like a copy of all this code, I will post all of this in the comments section down below. But yeah, those are a few loop control statements in Python. What's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to explain lists in Python. So sit back, relax, and enjoy the show. All right, ladies and gentlemen, let's get down to business. I got to explain lists to you all. Now, a list is used to store multiple items within a single variable. For example, let's say we have a variable called food, and I will store a string value of pizza because I like pizza. What we could do is that we can store multiple items within this variable by turning this variable into a list. And in order to do so, we're going to surround all of the values that we would like to add to our list with a set of square brackets. And boom, there you have it. We now have a list called food. It is no longer a variable. So what we could do is add multiple items to this list of food. So let's add some other food items that we might like. Let's see, I also like maybe some hamburgers and a hot dog and maybe some spaghetti. I think I spelled spaghetti right. Okay, so we now have a list called food. Now what happens if we attempt to print this list of food? So print food. So this will print all of the elements found in this list. Each item in a list is referred to as an element. If we need to access a certain element of this list, we have to list the index. So next to our list, we'll add a set of square brackets again, and we need to list the numbered index of the element that we're trying to access. Now computers, they always start with 0, so the first element in our list would be element number 0, the next one would be 1, 2, and 3. So if we need to access element 0, which is in the first position, we would say food, square brackets, and then within here, list the index. So the first position is 0, and this will now print the first element of our list, which is pizza. Let's attempt to access some of these other elements. So the element at index 1 would be, you guessed it, hamburger. 2 would be hot dog, and 3 would be spaghetti. Now what happens if we attempt to access the element at index 4? Well, currently that's out of range because we did not assign a value. So we're experiencing an error, an index out of range error. But if I were to add another element, let's say pudding. All right, well then the element at index 4 would be pudding then. One important concept with lists is that you can always update and change the elements found within a list later on in the program after you declare one. So let's say we would like to immediately change one of these elements. Let's say food. At index 0, I want to replace with maybe sushi because sushi is great. So if I were to print the element at index 0, this would no longer be pizza because we updated element 0 to be sushi then, and this prints sushi. Now, if you need to display all of the elements found within a list, you can easily do so with a standard for loop. What we'll do is say for x in the name of our list, which is food, print x. And let me turn this line into a comment. All right, so this for loop will print all of the elements found within our list of food. And the results are sushi, hamburger, hot dog, spaghetti, and pudding. All right, people, for this next portion, I'm going to demonstrate a few useful functions of lists. And to access some of these functions, type the name of your list, dot, and there's a bunch to choose from here. Let's begin with append. We can add an element to this list. Let's say at the end, I would like to add ice cream. So then if I were to display my list, we now have ice cream at the end because we appended this value to my list of food. So let's go over a few others. So we can also remove a value, food.remove. Let's say I would like to remove hot dog. So I'm going to type that within my function, and this will remove hot dog, and that is no longer here. Next, we can pop. Food.pop. Pop will remove the last element, so this will remove pudding. We can insert a value at a given index. Food.insert. We need to list an index. Let's say 0. That would be the first position. Technically, that's where pizza is currently. And I would like to add cake. And at index 0, we now have cake. So next up, we have sort. Food.sort. This will sort a list alphabetically. So in the first position, we have hamburger, hot dog, pudding, spaghetti, then sushi. We can also clear a list. Food.clear. And this will remove all of the elements of a list. So this will not print anything because we cleared the list. Well, everyone, in conclusion, a list is really just a variable that can store multiple values. Think of it that way. So if you would like a copy of all the code that we have written here today, I will post all of this in the comments down below. But yeah, that's how lists work in Python. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain 2D lists in Python. So sit back, relax, and enjoy the show. I have a super quick video for you all today on 2D lists, also referred to as multi-dimensional lists. All it is a list of separate lists. So let's begin by creating a few separate lists. Let's say we have a list called drinks, and let's assign a few values. Let's say we have coffee as well as soda and maybe some tea. All right, so we currently have one list. Let's make maybe two more. Let's make a list called dinner. And maybe in here we'll place pizza, then hamburger, and hot dog. Okay, then let's create one more for this example. Let's say dessert. And maybe we'll add 2 items. They all don't need the same amount of items or elements. So we have cake and ice cream. All right, so we have 3 lists, one called drinks, dinner, and dessert. So what we can do is add all of these lists to one list, and let's create a list called food. Food equals, and for each of these elements, we're going to place our lists. So we have drinks, dinner, and dessert. Check this out. What if I were to print my 2D list of food? So what ends up happening is that this will print all of the elements found within each individual list, and they're all grouped together. So this first portion is my drinks list, which contains coffee, soda, tea. This next element is my dinner list, which contains pizza, hamburger, hot dog, and the last element, dessert, contains cake and ice cream. If I need to access just one of these lists, I will add an index after my food 2D list and set an index number. So index 0 is referring to my first list of drinks, and this will display all of the elements found within my first list. And if I need just one of these elements, I will add a second set of square brackets and list the index of the item that I'm trying to access. So this very first item, coffee, would be index 0 and then index 0 again. So we need 2 sets of square brackets. And if I were to print this, this will display coffee. So if I go down the list, the next element would be soda and then tea. If I were to change the index within this first set of square brackets, well, now we're working with a different list. This time we're working with our dinner list. So the element at index 1, index 2, that would be our dinner list, and this will display the element of hot dog. If I change this to the next list, which would be dessert, well, we're going to receive an index out of range error because we only have 2 values within this list, cake and ice cream. There is no element at index 2 because we only added 2 elements to this list of dessert. All right, everybody, so that is 2D lists, also referred to as multidimensional lists. It's a list of separate lists. If you need to access one of the elements within your 2D list, you need 2 sets of square brackets. So if you would like a copy of this code, I will post this in the comments down below. But yeah, that's how 2D lists work in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to explain tuples in Python. So sit back, relax, and enjoy the show. So tuples, they are collections which are ordered and unchangeable. They're very similar to lists, but they're ordered and we can't change them. They're useful for grouping together related data. Let's say we would like to create some sort of student record. So we can create a tuple to take care of that for us. So let's say we would like to create a tuple called student. The process of creating a tuple is very similar to lists, but instead of using a set of square brackets to place all of the values within, we're going to use a set of parentheses. And now we can add a bunch of values related to this collection of student. So let's add some student information. Let's say that this student's name is Bro. Let's give him an age as well as a gender. All right, so there you have it. We now have a tuple called student. And let's take a look at some of the functions related to tuples. And you can access them by typing student dot, and then there are a few here, not as many as lists. We have count and we have index. So we can find the count of how many times a value appears. Let's count how many times the value of bro appears. So we'll need to put this within a print statement so we can actually see it. So bro appears 1 time within this tuple. There is also an index method as well. So type the name of your tuple dot, and we will use the index method. We can find the index of a certain value. Let's say we would like to find the index of male, and then I will just print this to the console window. So the index of the value male would be at 2, 0, 1, 2. That's it for the methods available to tuples. A few tricks that you can do with tuples is that you can display all of the contents within a tuple using a for loop. Let's say for x in student, we will print x. So this will iterate once through all the values found within our tuple of student. And we can also check to see if a certain value exists within our tuple using an if statement. Let's say if bro in student, if this is true, then what do we want to do? Let's say print bro is here. All right, so since bro is within here, this will be true, and this will print our statement of bro is here. All right, everybody, like I said, this is a super quick video on tuples. They're very similar to lists, except they are ordered and unchangeable. If you'd like a copy of all this code, I will post all of this in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain what a set is in Python. So sit back, relax, and enjoy the show. A set is a collection which is unordered as well as being unindexed. They do not allow any duplicate values. For example, let's create a set of silverware. So in order to create a set, we need a name for this set. Let's call it utensils equals. And in order to create a set, we need to surround all values with a set of curly braces. Now let's add a few utensils to the set called utensils. Let's add a fork, a spoon, and maybe a knife, and that should be good. And let's display all of the values. For x in utensils, print x. Now with sets, they're different from lists because they're unordered as well as being unindexed. If I were to print all of the elements in utensils, they might not necessarily be in the same order in which we placed them. For example, when we printed all of the elements found within utensils, first we had a knife, a fork, and then a spoon. If I were to run this again, they might be in a different order, kind of like that. So a set is actually faster than a list if you need to check to see if something is within a set compared to a list, and they do not allow any duplicate values. Let me add a bunch of knives and let's see what happens. So I'll have a total of 3 knives, but when we print all of the elements of this set, only 1 knife appears. So here's a few useful methods of sets. The first method is that we can add an item to our set. So type in the name of the set, in this case it's utensils, dot, and here's a bunch of methods that you can use. I am looking for add, and we can add an element to the set. I would like to add a napkin. And then if we were to print the set, we do have a napkin within the set. We can also remove an element. Utensils dot remove. And I would like to remove the fork. And now our fork is gone. We can also clear. Utensils dot clear. And all of the elements within our set should be gone. So let me turn these lines into a comment. All right, for this next example, we'll need a second set. Let's create a second set called dishes. And then we need a set of curly braces. And let's add a bowl, a plate, and a cup. Our next method is that we're going to add one set to another by using the update method. Let's say we would like to add our dishes set to our utensil set. So let's type utensils dot and use the update method. And within this method, we will pass in the set that we would like to add. So utensils update dishes. This will add all of the elements found within dishes to our utensil set. And you can see that when we print our utensils, we have a bowl, a plate, and a cup in here as well. And then if I were to switch these around, let's say dishes update utensils. And then I will print everything found within dishes. Now there's a fork, a spoon, and a knife in here as well. We can also join 2 sets together and create a new set entirely. So let's create a set called dinner table, like we're setting up a dinner table and we need a fork, a spoon, a knife, a bowl, a plate, and a cup. So we have a dinner table set. We're going to set this equal to either utensils dot union dishes, or we could do dishes union utensils. Either way would work. And let's display all of the elements found within dinner table, and we should now have elements from both sets, utensils and dishes as well. There are also some methods in which we can compare the similarities as well as the differences between the elements found within 2 sets. Let's say I would like to check to see what utensils has that dishes doesn't. And for this example, I think I'll add a knife to my dishes set, just so that they have at least one thing in common. So I would like to see what utensils has that dishes doesn't. So we can do so using the difference method, and I will print the result with a print statement. So I'm going to compare utensils against dishes. Utensils dot difference dishes. And this will print what utensils has that dishes doesn't, which is a fork as well as a spoon. And we can reverse the roles too. We could say dishes, difference, utensils. What do dishes have that utensils doesn't? And dishes has a cup, a bowl, and a plate. They both have knives, so that's why knife isn't appearing. We can also check to see if there's anything that they have in common using the intersection method. So I'll turn this line into a comment. We'll print utensils dot intersection dishes, and this will return whatever element that they have in common, which is a knife. Alright everybody, in conclusion, a set is a collection which is unordered as well as being unindexed. They do not allow any duplicate values, and you can do things like compare two sets, see if there's anything that they have in common, any differences, and we can add or remove elements to a set. If you'd like a copy of all this code, I will post all of this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how dictionaries work in Python, so sit back, relax, and enjoy the show. Alright, let's get down to business. A dictionary is a changeable, unordered collection of unique key value pairs. They're fast because they use hashing, and they allow us to access a value quickly. Now, to create a dictionary, it's very similar to creating a set based on the last video, except we're going to store unique key value pairs. Let's create a dictionary of countries and their capitals. We can store those as key value pairs. So let's call this dictionary capitals. Capitals equals, then we need a set of curly braces, much like what we use with sets. Now we need a key and a value. Let's say we have the USA as a key, and the capital of the USA would be Washington, D.C. So in order to associate a value with a key, we'll follow the key with a colon and then add some value. And the data type really doesn't matter, but in this case, we're just using strings. So the capital of the USA would be Washington, D.C. And to add another key value pair, we'll separate each with a comma, and let's add a few others for good measure. So let's say we have India next as a key, and the value would be New Delhi. And we'll add two more. Let's say we have China, and the capital of China is Beijing. And lastly, let's add Russia. And the capital of Russia is Moscow. And there you have it, ladies and gentlemen. We now have a dictionary called capitals that has unique key value pairs. So remember, with dictionaries, they are unordered. In order to access one of these values, instead of using a numbered index, we're going to use the associated key with that value. Here's an example. Let's say I would like to print the capital of Russia. So I need to use this key of Russia. So in order to do this, type in the name of the dictionary, followed by a set of straight brackets, and then instead of an index number like 0 or 1, 2, 3, I'm going to use the key. So I would like to print the value that's stored or associated with the key of Russia. So when I run this, this will print that value, which is Moscow. So this isn't always safe. Let's say we have a key that doesn't exist, like Germany. Germany is not currently within my dictionary. So if I were to run this, well then my program is going to encounter an error, and this will interrupt the normal flow of my program. A much safer way to access a key to check to see if it's there or not is to use the get method of dictionaries. So I'm going to turn this line into a comment, and let's try this again, but this time we'll use the get method. So type in the name of the dictionary dot get and list the key that you want to use. So I would like to see if Germany is within my dictionary. Currently there isn't, so this will return none, and we will not encounter an error. So this is a much safer way of checking to see if there is a key within your dictionary. Here's a few other useful methods. There is a method to print only the keys. So we type in the name of the dictionary, capitals, and here's a listing of all of the methods that we have access to. I'm looking for the keys method, and this will print only the keys and not the values. We can also print just the values and not the keys. So type in the name of the dictionary again, capitals, dot, values. And this will print only the values. Or you could print everything, both the keys and the values. And you do so by using the items method. Capitals, dot, items. And this will print your entire dictionary. One other way in which we can display all of the key value pairs in a dictionary is to use a for loop. So at the end, let's create a for loop. For key, comma value in capitals dot items. This is going to iterate once for each key value pair in my dictionary. For each key value in capitals dot items, print key, comma, value. And this will print my entire dictionary. A feature of dictionaries is that they are mutable. That means we can change them or alter them after the program is already running. So one way in which we can do that is to use the update method of dictionaries. So let's add Germany as a key and give it a value of Berlin. So type in the name of the dictionary, capitals, and we'll use the update method. And within the parentheses of this method, we'll add a set of curly braces. And now we can add a new key value pair. So let's add Germany and a value of Berlin. So if I were to run this and display all of the key value pairs found within my dictionary, we now have Germany as a key and Berlin as its value. Not only can you use the update method to add a new key value pair, but you can update an existing one. Let's say we would like to change the capital of the USA. So capitals dot update parentheses curly braces list the key USA colon, and then we can give the USA a new value. Let's pretend that the United States government has decided to relocate their capital to Las Vegas. So this will now update our key of USA with a new value. And if I were to print all of the key value pairs found within my dictionary of capitals, the USA has a new value of Las Vegas. So the last two methods I'm going to cover are both pop and clear. You can use the pop method to remove a key value pair. So capitals dot pop parentheses and list the key of the key value pair that you would like to remove. So let's say we would like to remove China. So we'll list that key, and then when we use the pop method, that will remove this key value pair from my dictionary. And then of course we have clear as well, which will just remove everything. Capitals dot clear. And this will clear my dictionary. All right, everybody. So in conclusion, a dictionary is a changeable, unordered collection of unique key value pairs. They're fast because they use hashing, and they allow us to access a value quickly. Well, that's the basics of dictionaries in Python. If you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that's how dictionaries work in Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the index operator in Python. So sit back, relax, and enjoy the show. All right, people, let's begin. I'm going to be explaining the index operator, which is represented by a set of square brackets. Now, they give access to a sequence's elements. They include, but are not limited to, strings, lists, and tuples. For this example, we're going to be working with strings because strings are easy to work with. Let's say we have a name, and name equals whatever your first and last name is. We can use the index operator to access an element of the sequence, our string. So let's check to see if the first letter in our name is lowercase. And I should probably change that to lowercase for this example. So within an if statement, if name, and we can add a set of square brackets after our sequence, which is a string, and we can check a given element of our sequence. Let's check to see if the first letter is lowercase. Now, with computers, they always start at 0. If you need to access the first element in a sequence, that would be index 0. And then the next sequence, well, the next element in the sequence would be 1, then 2, then you follow that pattern. So I would like to check to see if name at index 0, that would be the first character, is lowercase. So there is a method to check that. Dot is lower. This will return true or false. If the first letter is lowercase, then our if statement is going to be resolved to true. And what I could do is that I can perhaps change it to uppercase then. So let's reassign name to equal name dot, and there is a capitalize function here. And then let's print our name. Print name. So when we run this, the first letter in my name is now capitalized. So if you need to access an element within a sequence, a string or a list or a tuple, you would add a set of square brackets afterwards, and then you list an integer of the element that you're trying to access. So here's a few other examples. I'm going to turn this as well as this into a comment. And let's say we would like to create some substrings, and we can do so using our index operator. So I would like to create a substring from the first part of my name. So what I'll do is create a new variable, first name equals name index operator. So you can specify a range for an index operator. So you would set the starting position on the left-hand side, followed by a colon, and then your ending position. So I would like this substring to begin at index 0 and end at 3. So that would be 0, colon, then 3. All right. And then I would like to make this all uppercase for some reason. And then let's print my first name. So with the index operator, we specified a range. We would like to access elements 0 through 3, turn them uppercase, and assign them to a new variable of first name. Here's a shortcut that you might find useful. If the index for your range begins with 0, you can actually delete that. You don't even necessarily need that 0. Now we just have colon 3, and this would work the same as it did before. So that's a useful shortcut, and we're going to bring it up later if we need to access the last element in a sequence. This time, let's create a substring of last name. So last name equals name index operator. This time, I would like to access the element at index, let's see, 0, 1, 2, 3, 4. All right, so I'm going to say 4, colon, and we're not really sure where our name, our last name, is going to end. So what you could do is just say colon and then leave the next index blank. So that will be the index beginning at 4 and everything afterwards. And let's say 2 lower to make this all lowercase for some reason. So let's print our last name. Print last name. So this should take everything starting at index 4 and after that and turn it into its own substring of last name. Now you can access the last element in a sequence by using what's called negative indexing. So let's add a exclamation point to the end of our name. So let's say we have a new variable called last character. And I would like to store the last character in my name to this new variable, this new substring. So to access the last element in a sequence within the index operator, we can use negative indexing. So the last element would be -1. All right. And then let's print whatever our last character is. So this should print an exclamation point. Yep, which it did. So then if this was -2, that would be the second to last element in a sequence. So now that would be E, because E is in the second to last element in my sequence. All right, everybody, so that's the basics of the index operator. You can add a set of square brackets after a string, a list, or a tuple, and then list an integer or a range of the elements that you're trying to access. So if you would like a copy of all this code, I will post everything in the comments down below. Don't be afraid to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain how functions work in Python, so sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Okay, let's do this thing. A function is a block of code which is executed only when it is called. This process is also known as invoking a function. With programming, we try not to repeat code if we don't have to. That's why functions are useful, because our function can perform some specific task for us, some block of code for us, whenever it is called. So we only need to write that block of code once, and if we need to repeat it, we just call this function one more time. So let's define and create a function. We'll create a function called hello, And in order to define a function, we'll type def and then a unique function name. So let's call this function hello. And with functions, they always end with a set of parentheses. And lastly, to finish defining this function, we'll add a colon at the end. So if you go down to the next line, take notice that my cursor is now indented. Any code underneath a function that is indented belongs to that specific function and will only execute whenever that function is called. So for now, we need to type in something. If you don't know what you want your function to do, you can always type pass for now. But let's print something. Print the word hello. And in order to call this function, all we need to do within our program is type the name of the function, which is hello, and then add a set of parentheses because functions always end with a set of parentheses. So what this will do is execute my function once and perform this block of code whenever it is called. If I were to remove this, well, our program currently isn't going to do anything because functions only execute their block of code only when it is called. So this time, let's print the word hello 3 times. So I will call this function 3 separate times. Hello, hello, hello. So when I run this, our hello function will be called 3 separate times. Now, with functions, they are not limited to just one line. This is an entire block of code, so maybe we can do something else too. Let's print, have a nice day. Now, if I were to run this, my hello function is going to execute this entire block of code 3 separate times. Hello, have a nice day. Now, an important feature of functions is that we can send our function some information, and our function can do something with that information that it receives. Let's say this time I would like to print hello plus somebody's name. Currently, name is an unresolved reference. What we can do when we call this function is send our function some information. This can be a value, a variable, a collection, all sorts of different things. So if you need to send your function some information, within the parentheses when you call that function, just list the data that you want to send your function. So let's say I would like to send my function a string value of bro, whatever your first name is. When you send information to a function, these are called arguments. They are the information that you're sending to a function. And when you define that function, you need a matching set of what is known as parameters. So our hello function is going to receive one argument, a string value. We need a matching number of parameters. Currently, this isn't going to work. You can see here that hello takes 0 positional arguments, but 1 was given. Our function needs a matching number of parameters. So think of it this way. When we receive this value, we're going to give a nickname to this value. So when we receive the string value, what do we want to call it? Well, let's call it name. So in order to add parameters to your function, just list the parameters within the parentheses of that function. And well, this should work now. We have a matching set of arguments and parameters. When we call the hello function, this time we are sending one argument over, and when our hello function receives this argument, we're going to give it a temporary nickname of name, or you can call this whatever you want to. And then we can use this value for whatever we want within our function. Now, if we were to run this, this will print, hello bro, have a nice day. Now I can send maybe a different value. Let's say hello, and then I will send a string value of dude. Hello dude, have a nice day. So this isn't limited to just values, we can send variables too. Let's say we have a variable called name equals bro. And this time I'm going to send this variable over, hello, and then send name. So these don't need to be the exact same. Let's say this is my name, and I'm going to send my name over, and I will temporarily give this value a nickname of just name. And then I can use this variable for something. Hello bro, have a nice day. Now, with arguments, you can send more than one value over. Let's say this time I would like to send 2 values over. So let's send bro, maybe for a first name, and code for a second name, but you can use your first name and last name. So this isn't going to work because we do not have a matching set of arguments and parameters. we're sending 2 arguments over, but our function is only designed to accept 1 argument because we have 1 parameter. So let's rename name as first name, and we need 2 parameters this time. So what are we going to call this value when we receive it? Let's call this last name. So this time we are going to receive 2 values. They will be nicknamed first name and last name. So this time let's print hello first name. Maybe I'll add a space plus last name. And this is now valid. Hello bro code, have a nice day. With arguments, you can mix and match the data types that you're sending as arguments. So currently we're sending 2 string values as arguments. This time, let's send an integer value. Let's say we would like to send an age over to our hello function. So I'll just send maybe the value of 21. So currently this isn't going to work because the hello function takes 2 positional arguments, but 3 were given. When we call this hello function, we're sending this argument over, but our function doesn't know what to do with this argument. So we need a matching parameter for this value that it receives. So let's call this value, maybe age, as a temporary nickname, and then we can do something with this value when we receive it. So let's print an additional message. Perhaps you are plus age plus years old. So if you need to display an integer or number along with the string, you do need to convert it to a string. So let's just cast our age as a string when we display this. So this should work now. We now have a matching number of arguments and parameters. So this will display, hello bro code, you are 21 years old, have a nice day. So ladies and gentlemen, in conclusion, a function is a block of code which is executed only when it is called. If I were to remove this function call, well then our program is just going to completely ignore this function and this block of code would not be executed. When we call this function, we can pass information known as arguments, but we need a matching number of parameters set up to receive these arguments. There are a few advanced features of parameters, but I'll hopefully get to that in future videos. We'll just stick with the basics for now of functions. So that's the basics of functions. If you would like a copy of this code, I will post this in the comments down below. But yeah, that is how functions work in Python. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain the return statement in Python, so sit back, relax, and enjoy the show. Alright people, let's begin. The return statement is used within functions to send Python values or objects back to the caller. These values or objects are known as the function's return value. So do you know how with functions we can pass arguments to a function, and then our function can do something with those arguments? Well, not only that, but our function can pass some value or object back to the caller. So what we'll do for this example is create a function that will simply multiply 2 numbers together and return the result back to the caller. So let's define a function called multiply, and we'll set up 2 parameters for this function. Let's say number 1 and number 2. And what we'll do is say result equals number 1 times number 2. And then at the end, we can return something. What do we want to return? Let's return whatever the result is. Now, when we call this function, we will pass in 2 values as arguments. Let's say we would like to multiply 6 times 8. So when we run this, while we can't actually see anything, when we return the result after multiplying numbers 1 and 2, it's going to return the result back to the caller. In order to see the value that is returned back to the caller, one way in which we can do this is to print the value that is returned within a print statement. So what we'll do is print the value that is returned after calling the multiply function. So 6 times 8 is really great. 6 times 8 is 48. Now, one other thing that we can do is store the returned value within a variable. So let's say x equals multiply 6 times 8, and then we will print whatever x is. So the result is still the same of 48. Now, with the return value, there is another way in which we could write this that uses less lines of code. So we'll delete this first line, And instead of returning a variable called result, what we'll do is just return number1 times number2. And this would work the same as it does before, but it's written in less lines of code. So that's another way in which you could write this. All right, everybody, so that is the return statement. Functions can send Python values or objects back to the caller. These values or objects are known as the function's return value. You can either print this value directly to the console window, or you can store it within a variable or some other location. And well, ladies and gentlemen, that is how the return statement works in Python. What's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain keyword arguments in Python. So sit back, relax, and enjoy the show. All right, everybody, let's discuss keyword arguments. These are arguments that are preceded by an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter, and we've been working with positional arguments already. And Python knows the names of the arguments that our function receives when we use keyword arguments. Here's an example of us using positional arguments, and then I'll demonstrate the benefits of keyword arguments. Let's say we have a function called hello that accepts 3 arguments, a first name, a middle name, and a last name, and the output will be hello, first name, middle name, last name. So if I were to run this, this will display hello, bro, dude, code. So we're using positional arguments. The order of the arguments does matter. What do you think is going to happen if I were to replace some of these values? Let's say I will swap the first argument with the third argument. So let's try it again. Hello, code, dude, bro. So obviously the order of the arguments matters. And now if we were to use keyword arguments, then the order of the arguments doesn't matter, but with each argument, we need to precede each argument with a unique identifier. And that identifier is the name of the parameter we want to associate each argument with. So for my intended last name, I will use an identifier of last to match this parameter. So dude will be middle, middle equals dude, and bro will be first, even though they're not in the correct order. So let's try this again. And my output is hello, bro, dude, code. So that's all about keyword arguments. They are arguments preceded with an identifier when we pass them to a function. The order of the arguments doesn't matter, unlike positional arguments, which do matter. And then Python knows the names of the arguments that our function receives when we use keyword arguments. So that's it for keyword arguments. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how keyword arguments work in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to explain nested function calls in Python. So sit back, relax, and enjoy the show. All right, people, nested function calls. These are function calls inside of other function calls. And this is possible because certain functions will return a value, and we can immediately use that value as an argument for the next function. So here's an example. Let's say that we have this small program where we will ask a user to type in a whole positive number. And let's say I don't. Let's say I type in -3.14, and then I'm storing that value within a variable named num. What I'm going to do is convert that number to a floating point number because currently it's a string. When you accept user input, I will find the absolute value of num and then round it to the nearest whole number and then print the value. So we can actually do this using less lines of code with nested function calls. So let's start with the first function, which will be accepting some user input, the input function. So this will be in the very center of our nested function calls. And then the next function we would like to apply to the variable that is returned, the value that is returned, we will pass in as an argument to our next function of casting this data type to a float. So we'll surround our function with another function and use the float function. And then we'll just keep on adding layers to this. So we have the absolute value function next. So we'll add another layer. And we have the round function. So we'll add a layer to that. And lastly, we're going to print, and that'll be the outermost layer. So this program will do the exact same thing. Let's say -3.14, except we've written this with one line of code. So basically, we start with the innermost function and resolve that first. Whatever value is returned, we use as an argument to the next outermost function. And in this case, it would be float. Then we resolve that, then move on to absolute value, then round, and then print. So it's just another way of writing code that takes up less lines, but this is more of an extreme example. You probably won't see like 4 or 5 nested functions. Well, everybody, those are nested function calls. If you would like a copy of this code, I will post all of this to the comment section down below. But yeah, those are nested function calls in Python. Hey, what's going on, people? It's your bro. Hope you're doing well. And in this video, I'm going to show you how variable scope works in Python. So sit back, relax, and enjoy the show. Alright, let's do a thing, people. Let's discuss the scope of a variable. Now, the scope of a variable is the region that a variable is recognized. A variable is only available from inside the region that it is created. Let's say that we have a function, and I just gave this function a name of display name. I created a variable inside of this function named name, and you can assign this a value of whatever your name is, preferably a last name for this example. And what I'll do is just print whatever my name is. So this variable is known to have a local scope because it's declared inside of a function. And a variable is only recognized inside of the region that it is created. This variable of name, since it's created inside of this function, it is known as a local variable that has a local scope. It's only available inside of this function that it's created. Now let's attempt to access this variable from outside of our function. So I'm going to print my name variable, but we'll have an issue though. So name is not defined. So local variables are declared inside of a function and they have a local scope. They are only available inside of this function in which they're created. On the other hand, a global variable is a variable that is declared outside of any function, but within your module that you're working with. A global variable is known to have a global scope. They are available inside and outside of any functions. Now, if I was to print my name variable, this is going to print bro, or whatever your first name is. And it is entirely possible to have both a global and local version of the same named variable. So we have both a global version of name as well as a local version of name. If I was to print my name variable from outside of this function, it's going to print my global version. However, if I print my version of name inside of that function in which it's created, we're going to first use the local version before the global version of name. And let's try that. So I'm going to call my display name function, and this will print my last name, code, and then my first name of bro. So it is possible to have a global and local version of the same named variable. Now, if I was to remove this line where we declare a local version of name, well then the next best available name to us would be the global version of name. So if you use a variable inside of a function, you'll first use a local version of that variable if it's available. If not, you'll use a global version instead. And Python will follow this rule known as the LEGB rule. You use any local variables first, then enclosed variables, then global, and then any built-in variables in that order. So that's the main difference between local scope and global scope. The scope of a variable is the region in which it's available, and it's limited to the region in which it's created. A local scope is available only inside of the function in which that variable is created. A global scoped variable is a variable that is available inside and outside of any functions, but within your module that you're working with. So that's variable scope in Python. If you would like a copy of this code, I will post this code to the comment section down below. And well, yeah, that's how variable scope works in Python. Hey, what's going on, everybody? It's bro. Hope you're doing well. And in this video, I'm going to explain the args parameter in Python. So sit back, relax, and enjoy the show. Alright guys and gals, let's talk about args. Now args is a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Here's an example of why it would be useful. Let's say we have a function called add that will accept two numbers as arguments and add them together and return the sum. So this works as intended, right? As long as we pass in only two numbers. But what if we need to pass in three numbers as arguments? Well, we can no longer use this add function because we have two parameters set up, but we're passing in 3 arguments. You can see here within my console window that we have a type error. Add takes 2 positional arguments, but 3 were given. And one way in which we can solve this issue is to use this args parameter. So what we're going to do is replace all of our parameters with asterisk args. And actually, the args portion isn't as important as the asterisk. Args is short for arguments, and you can really name this whatever you want. Just be sure that you have this asterisk, because with this asterisk, we're doing a form of packing. What we're doing is passing all of these arguments and packing them into a tuple. So let's rewrite this program. So let's say maybe sum equals 0, and then we will need to iterate through all of the items within our tuple because tuples are iterable. So let's say for I in args. What we'll do is say sum plus equals whatever I is, and at the end, when we escape the for loop, we will return our sum. So let's try it again and see if it works. Well, would you look at that? It works. Let's pass in a few other arguments for good measure. Let's pass in 6 arguments this time. All right, look at that. This does in fact work. So you can actually name this whatever you want. The important thing is to have this asterisk. So let's rename this as, I don't know, stuff. And let's try this again. Yep, it still works. With tuples, they are ordered and unchangeable. Let's attempt to edit one of these values. So let's say stuff at index 0 is equal to 0. And let's try and change it. So you can see that tuple object does not support item assignment. If you need to change one of the values within your tuple after you pack all of these arguments, you might need to convert this to a different collection. One way in which we can do that is to cast it. Let's say stuff equals, and we'll cast our tuple as a list, because a list can be changeable, it's mutable. So let's attempt this again. We'll cast our tuple as a list, and then edit one of the values, and then add all the values together. So to change one of the values, say the name of your collection, stuff in this case, let's say at index 0, this now equals 0. So now if we were to add all these items together, they should equal 20. There we go. So yeah, that's basically the args parameter. The name isn't as important as the asterisk because you can really name it whatever you want. A common convention is to just name this args. It's a parameter that will pack all arguments into a tuple. It's useful so that a function can accept a varying amount of arguments. Well, that is all about args. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how the args parameter works in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to be explaining kwargs in Python, so sit back, relax, and enjoy the show. Alright everybody, let's talk about kwargs. Now, this is a parameter that will pack all arguments into a dictionary. It's useful so that a function can accept a varying amount of keyword arguments. It's identical to args, except with args will accept a varying amount of positional arguments and pack them into a tuple. With kwargs, this will accept a varying amount of keyword arguments and pack them into a dictionary. So here's an example of why this would be useful. Let's say we have a function called hello that accepts 2 keyword arguments, a first name and a last name. All this will do is output hello, your first name and last name. But what if somebody has more than 2 names? Let's say somebody has a middle name. And for this example, I'll just say my middle name is Dude. So if I were to run this, well, this hello function is no longer going to work. As you can see in the console window, we have a type error. The hello function got an unexpected keyword argument middle. One way in which we can solve this, we can use this kwargs parameter so we can accept a varying amount of keyword arguments. So what we'll do is replace our parameters with 2 asterisks, then kwargs. Now, if I would like the same output as I had before, I'm going to need to change a few things around. In order to access a value within a dictionary, you type the name of the dictionary, square brackets, and then within quotes, list your key. So I would like to access the value at this key first. And let's repeat the process for last name. So the key is going to be last. We'll access this value at this key. And this should work the same as it did before. Now let's take this a step further. Let's say we would like to display somebody's full name based on the amount of keyword arguments that they pass into this function. Well, there's a few different ways in which we could do this. One easy way is that we could write our program like this. let's print the word hello, and we will need to iterate once through each key value pair within this dictionary, and we can use a for loop to do that. So to iterate once through each key value pair in your dictionary, we'll type for key value in the name of our dictionary, Quargs in this case, dot items, and then we will print each value. So there's one more thing that we need to do. This kind of works as intended, but it's going to print each value, including our word hello, on a new line. So with a standard print statement, this will print a new line character after each print statement as if we're hitting enter. We can actually change that. So after your string, add end equals, and we can replace that new line character with something else, maybe a space. And let's do the same thing for our for loop. So value, comma, end, and then just add a space. Now this will print all of your names all in the same line. Hello, bro, dude, code. And now we can pass in a varying amount of keyword arguments based on how long our name is. Perhaps we have like a title. Title equals Mr. And we can print that as well. Hello, Mr. Bro, Dude, Code. Here's a fun fact of the day. You don't necessarily need to name this parameter as Quargs. The important thing is to have these double asterisks that precede it. Quargs is just a common naming convention. It's short for keyword arguments. You could name this as something else, perhaps something more descriptive like names, since we're passing in a bunch of names. So the name of our dictionary is now names, and this would work the same as it did before. The important thing is to have these double asterisks that precede the name of your dictionary, but Quargs is the common naming convention. Well, everybody, that's all about Quargs. It's a parameter that will pack a varying amount of keyword arguments into a dictionary. If you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how Quargs works in Python. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about the format method in Python. So sit back, relax, and enjoy the show. Okay, ladies and gentlemen, let's begin. The format method is a method available to strings. It's optional, and it gives users more control when displaying output. To best demonstrate this, I'm going to use a line from a popular nursery rhyme titled Hey Diddle Diddle because, well, you know, I'm a mature adult like that. I'll be printing this line to my console window. The cow jumped over the moon. Let's do so using a standard print statement, and then I'll show you the benefits of using the format method later. For this example, I have two variables, a variable called animal, and I'm going to store a string of cow and item, and I'll be storing an item name, which is moon. When we compile and run this, as you would expect, the output is the cow jumped over the moon. There's a more elegant way of writing this line of code, and that is by using the format method available to strings. I'm going to turn this line into a comment, and we're instead going to produce the same output, but use the format method instead. So we need a standard print statement like usual, and then a string that we would like to format. So we're going to write the same thing, but in place of the variables, we're going to add a placeholder. Instead of the variable name or value name, I'm going to add a set of curly braces. So that functions as a placeholder for a value or a variable. This should be cow, jumped over and I'm going to insert another placeholder. Now this is a string. We can format the string by following this string with dot format parentheses, and within the parentheses of the format method, we can insert some values or variables. Let's begin with some values. I would like to insert cow as well as moon. So this will produce the same output, but it's written a little more elegantly. We can also replace these with variables because they store these values. So I'm going to replace cow with animal and moon with item, and this will create the same output as it did before. These curly braces are what's known as format fields. They function as a placeholder for a value or a variable, and they work in order. The first format field will insert the first value at this location. If you have another set or more sets of this format field, you'll insert the next value that's listed within the format method. So if we were to switch these around, we'll switch the position of animal with item. Well, then the first format field is going to insert our item, and the second format field will insert our animal. This time, the moon jumped over the cow. An additional way of inserting values at a given placeholder would be to use what's referred to as a positional argument. Within these format fields, we will list the index of the value that we would like to insert at this location. If you need to insert the first value, well, that has an index of 0 because computers always start with 0. And following that pattern, the next index would be 1. If you had, let's say, 3 values that you need to insert, if you had another placeholder, that would be 2 then. So you would just follow that pattern. So there's going to be no visible change. But what we could do is reverse the positional arguments of these placeholders. So what do you think would happen if I switched 1 with 0 at these locations? Well, this format field is going to insert the value found at index 1. This first value is index 0, and the second one is index 1. So now the roles are reversed. This time, the moon jumped over the cow. Our last way of inserting some values at a given format field would be to use what's referred to as a keyword argument. Within the format method, we're going to list some keyword argument pairs. We need a keyword name followed by a value. So let's say animal is going to be the keyword. We're going to say equals some value. Animal equals cow, and item equals moon. And you may have noticed that the color of your text might have changed. So we no longer need these variables actually, but I'm going to comment out these two print statements because we will get an error then. So these are in keyword argument pairs. And within our format field, instead of keeping these empty or using an index, we can use the keyword name. At my first format field, I'm going to insert my keyword of animal. And at my second format field, I would like to insert the item keyword. So the result is going to be the cow jumped over the moon. So let's reverse these now. We'll place our item keyword here, and then at the second format field, we will insert our animal. And this time, the moon jumped over the cow. Here's an important concept that I'd like to bring to your attention. With these values found within the format method, you can actually reuse some of these more than once. So let's say we would like to state the animal jumped over the animal. We're going to use this animal keyword twice, and our output is going to be the cow jumped over the cow. If we're doing the same thing with positional arguments, we can reuse the same index. This time, let's say that the moon jumped over the moon. So our item has an index of 1. So within our first format field, we'll state the index will be 1, and our second format field will also be 1. So our output's going to be the moon jumped over the moon. All right, let's take things up a level. There's an even more elegant way in which we could write all of this. What we'll do is store our string that we would like to format within a variable. Let's turn this line into a comment, and let's create a variable called text. Text equals the string that we would like to format, which is the format field jumped over the format field. And if we need to format this variable, we can just call the format method on it. So within a print statement, let's say text dot, and then use the format method and pass in the values that we would like to insert at these placeholders. So we're going to insert animal as well as item. So our result, as you would imagine, is the cow jumped over the moon. In this next section, I'm going to explain how we can add some padding to a string when we display it using the format method. Let's say we have a name variable and assign this a value of whatever your name is. So I would like to display my name along with a custom message. Let's say, hello, my name is, and then I'll use a format field here. So let's follow this string by using the format method, and I would like to insert my name at this location. So currently this will display, hello, my name is bro, or whatever else your name is. So we can add some padding either before our name, after, or we can add some padding to the left and the right hand side of our value that we have. So what we'll do to begin is let's add some padding to the right hand side of our name that we have. So within our format field, if we need to add some padding, within the format field add colon,
and then the amount of space you would like to allocate to displaying your value. So let's say 10. So I'm going to allocate 10 spaces worth of room to display my name. You can't really see it right now, but let's take a look. So I can't move my cursor past this line at the end of my name, but with my second line, I have all of this room to work with. So if I were to change my string that I have, let's say, nice to meet you, well then all of this padding that I have is going to be more evident. So we can add a number preceding with a colon to add some padding to a value, and then you can left align this, right align it, or center align it. So what I'll do is copy this line that I have. If you need to left align it, you use the less than sign, but there's going to be no visible change because that's already the default. If you need to right align, precede your number with a greater than sign, so your value is going to be right aligned. If you need to center this value, then use the caret. So this will center align your value within the padding that you have allotted. One question that you might have for me, and I'll try and answer that now because it's relevant. What if we need to add a positional argument or a keyword argument to our format field if there's already some text within here? So what you would do before the colon, you would just precede the colon with either your positional argument or your keyword argument, followed by colon and then whatever you want to add afterwards to format your value that you have. All right, ladies and gentlemen, we are near the end, and I promise that this is the last section. How can we format some numbers? Let's say we have a number variable, and this will equal the first few digits of pi, 3.14159. Let's pretend that we would like to display only the first two digits after the decimal. So we can do so using the format method. Let's print the number pi is, and then I'll use a format field here, and we will call the format method and insert our number that we have. So if I need to display only the first two digits after the decimal within the format field, I will add colon dot to f. F is for floating point numbers. That's anything with a decimal portion. So the result is that this will display only the first two digits after my decimal because we placed 2 within the format field. So if this was 3.3f, this would display 3 digits after the decimal portion. Oh, and apparently this will round your number, so that's something that you should keep in mind. So this time, let's change our number to something larger like 1000. And I will copy this line and make a few changes. Let's say the number is, and I would like to add a comma at the thousands place. So after the colon within the format field, I will add a comma. So this will automatically add a comma to all 1000th places. Another cool thing that you can do is that you can display your number as binary. So within the format field, add :b. This will display a binary representation of your number. You can do the same thing with octal by adding :o. So our number is now being displayed as an octal number, and you can do the same thing with hexadecimal, lowercase x for lowercase or uppercase x for all uppercase. So my number 1000 is now in hexadecimal. And lastly, we can display this number in scientific notation using either lowercase e for lowercase or capital E for uppercase. And my number 1000 is now in scientific notation. All right, everybody, so that's a few things that you can do with the format method. It's an optional method that gives users more control when displaying output. If you would like a copy of all the code that we've written here today, I will post everything in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.
Hey, what's going on, everybody? It's your bro. Hope you're doing well, and in this video I'm going to explain a few useful methods of the random module, so sit back, relax, and enjoy the show. Okay, people, in this video I'm going to explain how we can generate some random numbers as well as a few other useful methods of the random module. Now, we're not going to be creating true random numbers, but something called pseudo-random numbers, which are fairly darn close. So the first step is to import the random module at the top. Import random. We now have access to everything that the random module has to offer.
Let's begin by generating a random number between 1 and 6, like we're rolling a dice. So what I'm going to do is say x equals random dot rand int, and we can generate a random integer between a certain range. If I want 1 through 6, I will state 1, 6, and then we can generate a random number between 1 and 6 like we're rolling a dice. So if I were to print the value of x, then we will get a random number between 1 and 6. For example, I just got a 1, a 2, a 3, and a 6. All right, we can also generate a random floating point number too. Let's say y equals random dot random. So this will give us a random number between 0 and 1. This time I'm going to print y. So we have 0.49 and some change, 0.145, and 0.858. We can also generate a random choice from a list or other collection. Let's say we're playing a game of rock, paper, scissors. So let's create a list. I'll just call this my list equals square brackets, and we will have 3 choices: rock, paper, and scissors. So let's say z will be the random string that we generate. Z equals random dot choice, and we will pass in my list. And let's print z. So this will generate a random choice from my list called my list. So we got scissors, paper, and rock. We can also use the shuffle method of the random module to shuffle a list or other collection. Let's say we're working with a deck of cards. Cards equals, let's say 1 through 9. And we have a jack, a queen, a king, and an ace. This won't be a full deck of cards, it'll just be one suit. So we can actually shuffle this list by using the shuffle method. Random dot shuffle. What do we want to shuffle? We want to shuffle our cards. And I will display my cards with a print statement. So the shuffle method will shuffle a list or other collection for you. Well, everybody, that's a few useful methods of the random module. If you would like a copy of all this code, I will post this in the comments down below. Don't be afraid to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.
Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain exception handling in Python, so sit back, relax, and enjoy the show. Well, everyone, let's talk about exceptions. An exception is an event detected during execution that interrupts the normal flow of a program. Here's a program that I've written, and we're intentionally going to cause an exception. So this program that I've written, we will accept a numerator and a denominator from the user. We'll divide the numerator by the denominator, we'll get a result, and print the result. So what if I were to divide a number such as 5 divided by 0, which we cannot mathematically do? Well, this will cause an exception, an event detected during execution that interrupts the flow of a program. So our program was interrupted, and within our console window we have this traceback message, which states what went wrong and a name for this exception that occurred. This specific exception that occurred is a 0 division error. So this video is all about handling these exceptions so they do not interrupt the normal flow of a program. Now, a very basic form of exception handling is to surround any code that is considered dangerous, as in it might cause an exception within a try block. Anytime you accept user input would be a good indicator too. So this code is considered dangerous because we don't know what the user is going to type in. So we will try all of this code. If an exception occurs, we can catch it and handle it. So to do that, we'll add an except block, except, and then we will catch exception. Normally, having this block by itself isn't considered good practice, but I'll explain why later. So this except exception block will catch all sorts of different exceptions, and it will prevent our program from being interrupted, and we can do something else entirely, such as print a message. Something went wrong. So let's try this again. We will divide 5 by 0, which we cannot do. We no longer have that traceback message within our console window. We caught the exception and we did something else. We printed something went wrong. Like I said before, it's not considered good practice to have a single except block that will handle all exceptions. It's much better to first handle specific exceptions when they occur, and we can do so by writing additional except blocks. So let's create an additional except block that will catch any zero division error exceptions. That occurs when somebody attempts to divide by zero. So if this exception occurs, how do we want to handle it? Let's just print a message. Let's print you can't divide by 0, idiot. And let's try this again. So 5 divided by 0. You can't divide by 0, idiot. Here's another one. I'm going to turn this except block into a comment so we can take a look at something. What if I divide by something that's not a number? Like we take 5 and divide it by the word pizza. Well, pizza's not a number, and we ran into a value error exception. So we should probably handle this too. So let's create another except block that will handle that. Except value error. And how do we want to handle this? Let's print something. Enter only numbers, please. Okay, let's try this again and see if this exception is caught. 5 divided by the word pizza. Enter only numbers, please. Not only that, but you can also add the exception block at the very end, just in case there's something you won't anticipate. But it's always considered good practice to first catch any specific exceptions and let the user know exactly what went wrong. An additional way in which we can handle these exceptions is that we could display the exception that occurs, although it is completely optional. So to do that, what we'll do is that after each of these except block definitions, let's add as e. So we're calling the exception as e. That's just standard practice, although it's not necessary. So let's do that for each of these except blocks. And then we can print whatever e is. So let's add that to each of these blocks. So it should now look something like this. So when we encounter an exception, we can display what exception occurred to as well. So let's divide 5 by pizza. Invalid literal for int with base 10. Pizza. Enter only numbers, please. So like I said, this is an additional way in which you could handle an exception, although it's entirely optional. Another thing that you can do is that you can add an else statement to the end of your except blocks. So what's happening here is that we're going to try all of this code. If an exception happens, then catch it and handle it. If not, then do something else. So why don't we print our result only if there are no exceptions that occur? So if there are no exceptions, we will execute this else statement. If not, then we won't. So let's divide 5 by an actual number this time, like 2. So there are no exceptions that occurred, so we executed this else statement, whatever code is within our else block, and this printed the result of 2.5. But if an exception were to occur, like we divide 5 by 0, then we will catch our exception and handle it, and we do not execute whatever block of code is within our else statement. There is one other clause that you should be aware of. That is the finally clause. This is always at the end. How this works is that whether or not we catch an exception, we will always execute any code that is within the block of code for our finally clause. So this is a good opportunity if you open files to close them within the finally block. But we haven't dealt with opening files yet, so we won't do that. All we'll do is just print something. Print this will always execute. So whether or not we encounter an exception, this finally block will always execute at the end. So let's try this again. So this time, let's cause an exception. Let's divide 5 by 0. You can't divide by 0. This will always execute. And this time, let's take this seriously and divide 5 by another number such as 3. So this will give us a result. And like I said, the finally clause, the code within the finally clause will always execute. But we won't really be working with this until we get to the section on file handling. Well, everybody, those are exceptions in Python. They are events detected during execution that interrupt the flow of a program. And we can handle these exceptions by using try and except blocks. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that is how exceptions work in Python. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video we're going to be covering some basic file detection using Python, so sit back, relax, and enjoy the show. Welcome, ladies and gentlemen, to the beginning of a mini-series involving doing stuff with files using Python, and in this video we're going to be doing some basic file detection. And in order to do so, I recommend importing the OS module. It's already included with the standard Python library. All you need to do is import it. All we'll be doing is checking to see if a file exists someplace on our computer. So we'll probably need a file to work with. What I'm going to do is go to my desktop for convenience and just create a new text document. I will call this test.txt. Now, I probably need the file location, so I'm going to copy that, and then we can use this. So let's create a variable called path that will include the path to the file that I would like to detect. So that was test.txt. Now, if you have backslashes in your file path, you'll probably need double backslashes because that's the escape sequence for a backslash within a string. So we now have this variable path that we can work with. Now I would like to check to see if this location exists on my computer. So if os.path.exists, and you can see that we can pass in our path as an argument. So I will pass in my path, and if this returns true, if that location exists, I will print that location exists. So this will not tell me if this is a file or not. We'll be covering that later. Else, let's print that location doesn't exist. All right, so if this location exists, this will return true. If not, this will execute our else statement. That location exists. So what if I were to delete this file and we run this program again? That location doesn't exist. Now, this won't tell you if the location you're dealing with is a file or not. There is a separate function for that. It is if os.path.isFile. What we'll do is pass in our path and print that is a file. All right, so let's create another file because I deleted the previous one. Test.txt, it's in the same location. Let's run this again. That location exists. That is a file. Now, what if this was a folder? So I'm going to create a new folder. I will call this folder. I will delete my test document. And let's change the location to folder. That location exists, but it is not a file. You can check to see if a location is a directory. So let's write an else if statement. os.path.isDirectory, and we will pass in our path. And let's print that is a directory. All right, so we have our folder. We're going to check to see if this location exists and if it's a file or a directory. That location exists. That is a directory. Well, everyone, that is the basics of file detection. We'll be building upon this concept in future videos. So if you would like a copy of this code, I will post this in the comment section down below. But yeah, that is the basics of simple file detection using Python. Hey, what's going on, everybody? It's Bro. Hope you're doing well. And in this video, we're going to be reading a file in Python. So sit back, relax, and enjoy the show. Welcome back, guys and gals. In this video, I'm going to explain how we can read the contents of a file using Python. So we'll probably need some sort of file to work with. I created a plain text file called test.txt. It's a plain text file, and all this says is, OMG, you can read this. Have a nice day. Like, comment, and subscribe. So what I would like to do is to read the contents of that file line by line and print it to the console window. And here's how. And honestly, we only need 2 lines of code to do this. So what we'll do is type with open, then within the open function, list the name of your file or the file path. This file of mine is within my project folder, so I only need to list the file name. If this was someplace else, you'll probably need the file path. So let's say this was on my desktop. Well, I'll probably need to list the file path of where that file is located, and I'll need to use double backslashes because that's the escape sequence for a backslash. But since this file is within my project folder, I only need to list the file name. So with open, then the name of your file or the file path as file, then what we're going to do is print file dot read. And that is it. So let's test it. And it works. OMG, you can read this. Have a nice day. Like, comment, and subscribe. So this will actually close files automatically after opening them, so that's kind of convenient. And let's just test that theory. So I'm going to print file.closed. If my file is in fact closed, this will print true. If it's still open, this will print false. So normally when you read a file, it's normally open and you need to close it manually, but if you write your program this way, with open, this will close the file automatically for you. So using with open will close any files automatically for you after they've been opened. However, this does not catch and handle any exceptions that might occur, like if we cannot locate this file. So let's say that I mistype the extension for this file. Let's say that I type in test.tx. That's kind of funny because tx is the abbreviation for Texas. It's a Texas file. So this will cause a file not found error, and this will interrupt the flow of our program, and we would probably like to prevent that. So what we could do is write a try and an except block. So we will try all of this code. If we cannot find this file, we can handle this exception, file not found error. So we'll place all of this code within the try block. Then if an exception happens, we will catch that exception. Except we would like to catch any file not found error exceptions. And let's handle this by printing that file was not found. So if I were to run this again, we will catch and handle this exception, and this will not interrupt the normal flow of our program. Well, everybody, that's how to open and read a file in Python. If you would like a copy of all this code, I will post this in the comment section down below. But yeah, that's how to open and read a file using Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be writing files in Python, so sit back, relax, and enjoy the show. So to begin, it's kind of similar to the last video on reading files. With open, within the open function, list the file name or the file path. So what do you want to call this file? I will call this file test.txt. Now normally with the open function, there is a mode, and you can actually change that. There's a second argument that you can pass in. By default, this is R for read, but if you want to write a file, this would be W. So now we're going to write a file called test.txt. So to finish, with open as file, what are we going to do? File.write. And within the write function, we can write some text. So let's create a text variable and we will add a string. So let's say text equals yo. And if you need to go down to a new line, be sure to use the new line character. So after this new line character, the text that comes after is going to be on the next line as if we're hitting enter. So yo, this is some text. Have a good one. Alright, so after I run this program, we should have a file, a text file within our project folder that appears. And it is right here, and it says, yo, this is some text. Have a good one. Now, this is in write mode. If this text was something else, it will actually overwrite your current file. So if I were to change this to, this text has been overwritten, well then this will overwrite the text that we have. This text has been overwritten. So you can actually append a file by changing the mode to A for append. So let me change this back. We will rewrite this. This will save over our current file. Now we can append some text. So let's add maybe a new line. Have a nice day. See ya. So I would like to append some text to this file. I'm going to change the mode to A for append. And we can now append some text onto the end of this file. Well everybody, that's how to write to a file and or append a file. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that's how to write to and or append a file in Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be copying files in Python, so sit back, relax, and enjoy the show. Welcome back to another video regarding doing stuff with files using Python, and in this video we're going to be copying some files. And in order to do so, I recommend importing the shuttle module. There's other ways of doing this too, but I tend to like using the shuttle module. Now, with this module, there are three basic functions to copy a file. Starting at the top, they are copy file, copy, and copy to. So copy file is what we'll be working with. This will copy the contents of a file. Copy will do everything that copy file does, plus copy the permissions mode, and the destination can be a directory. And lastly, copy to. This will do everything that copy does, plus it copies the metadata of that file, including the file's creation and modification times. So depending on the project or the program you're working with, you may need to use copy or copy to, but in this video, we're going to be using copy file just to copy the contents of a file. Now, after you import the shuttle module, this is all you need to do to copy a file. Shuttle dot, then use the appropriate function that you need to copy your file. We're going to be using copy file. Copy file, and within this function there are two arguments, a source and a destination. So within my project folder I have a plain text file called test.txt. All this says is, yo, this is some text. See ya. What I would like to do is copy this file because it's cool. Now, since this file is within my project folder, I only have to list the file name. Otherwise, if this is someplace else, I would list the file path here. So this file is test.txt. This is the source file, and now I need a destination. So the second argument will be separated with a comma. I'm going to list a destination. So you can actually rename this too. I would like to name this as copy.txt. So the destination is my project folder. So when I create a copy of this file, test.txt, this copy will appear in my project folder and say the same thing. So after running this, we now have a file named copy.txt that says the same thing as my test file. And remember what I said, you can copy this file to a different location on your computer, so you could list the file path. So this file path would go to my desktop, and then when I run this, this will copy my original file, my source, and then copy it to wherever my destination is. Oh, and I almost forgot. So if you need to use copy or copy to, the arguments are exactly the same. So if you needed to use copy, this would be shuttle.copy instead of copy file. Then copy to is shuttle.copy to. The arguments are exactly the same, but each of these functions will copy different things depending on what you need for your own program or project. All right, everybody, so that's the basics of copying files in Python. I will post this in the comment section down below. But yeah, that is how to copy files using Python. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video I'm going to explain how we can move files using Python, so sit back, relax, and enjoy the show. Welcome back everybody to another video regarding that thing that we do called programming, and in this video we're going to be moving files using Python, and in order to do so I recommend importing the OS module. This is included with the standard Python library. All you need to do is import it. And now let's create two variables. A variable called source that will hold the location of where our source file is located, as well as a variable called destination to function as well, the destination. Now for this video, I'm going to move a file within my project folder to my desktop. So to do so, I'm going to create a new file. I will name this test.txt, but take the liberty to name this whatever you want. So I'm going to list the location of where my test file is located. Since this is within my project folder, I only need the file name. If this was someplace else on your computer, you would probably need the file path. And now, where would I like to move this file to? I would like to move this file to my desktop, so I just need the file path. So I'm going to go to my desktop, right-click, go to Properties. I'm going to copy this location and paste it within my destination. And I will add /desktop/test.txt. You can also rename this too if you want. I will just keep it the same. Now, if you have single backslashes, you'll likely need to change these to double backslashes, because that is the escape sequence to print a backslash within a string. So we have a source location as well as a destination location. Now we can begin. I would recommend writing our code within a try and except block to handle any exceptions. So I would like to handle any file not found error exceptions, just in case our program cannot locate our source file. So let's print a message if that is the case. Perhaps source plus was not found. Now within our try block, let's check to see if there is already a file at this destination, because I would not like to save over it if there's already a file there. So let's do some basic file detection. If os.path.exists, and I will pass in my destination as an argument to the exists function. So if there is already a file here, I should probably let the user know. Print, there is already a file there. Else, we can replace our files. Honestly, if you do not care about saving over any files, you can omit this part. So else os.replace, and we will pass in our source and our destination as arguments. And let's print a message to the console window to let the user know that source plus was moved. All right, let's try this. Oh, I accidentally deleted my file, test.txt. All right, now this should disappear in 3, 2, 1, and it's gone. Test.txt was moved, and it should now be on my desktop, which it is. Now you can also use this to move a directory as well. I'm going to create a new directory. I will name this folder, and I will change source to folder, and the destination from test.txt to folder. And now this should move my folder. There is already a file there. Oh, let's delete that. Okay, folder was moved. All right, everybody, so that is how to move a file and or directory using Python. If you would like a copy of this code, I will post this in the comment section down below. But yeah, that is how to move a file and or directory using Python. Hey, what's going on, everybody? It's Bro, hope you're doing well, and in this video I'm going to teach you guys how we can delete files using Python, so sit back, relax, and enjoy the show. Alright everybody, so in this video we're going to be deleting files using Python, and in order to do so I recommend importing the OS module. This is already included with the standard Python library. All you need to do is import it. And now we need a file to work with, so let's right click on our projects folder and go to new, file. I will name this test.txt, and we now have a file that we can work with. But you know what, I would like to delete this file because it's lame, so let's do that. In order to delete this file, let's type os.remove, and we're going to list the file path here. Since this file is within my project folder, I only need to list the file path, test.txt. If this was someplace else on my computer, I would probably need the file path like that, but since this file is within my project folder, I only need the file name. Another thing that you can do too, at least what I like to do, is that I like to pass in a variable called path. I will make this a variable and assign it a string value of whatever the path to my file is. So I will assign path, the name to my file, test.txt. Now when I run this, this will delete my file test.txt, and you can see that it's no longer there. Now what if we attempt to delete a file that doesn't exist? Well, we'll encounter an exception. So if you want, this is optional, we can do some exception handling. So let's write the remove function within a try block, and we will catch this exception, file not found error. And let's print something. Print that file was not found. Now, if you attempt to delete a file that doesn't exist, your program will not be interrupted, and instead you'll print something, that file was not found. Now, this function does not remove empty folders. This is how to do so. And actually, let's test that. So let's create a new directory. I'll call this empty underscore folder. Now I will attempt to delete this empty folder. Empty folder. We encountered a permission error. Access is denied. So let's create an accept block for that. Accept permission error. Print, I don't know, you do not have permission to delete that. All right, to delete an empty folder, there is a different function, os.rmdir, short for remove directory. We're going to list the file path and pass that in as an argument. And let's create an else block as well because we can. Else, if there are no exceptions, let's print path plus was deleted. All right, so rmdir, remove directory, will delete an empty directory. Empty folder was deleted. Now, this function will not delete a folder that contains files. And let's try that. So let's create a new directory. I'll just call this folder. And within this folder, I will create a new file, test.txt. All right, let's attempt to delete this folder. I will probably need to change the file name. Let's change that to folder. And we encountered an OS error. That directory is not empty. So let's handle this exception. We don't need to, but I like to. Except OS error, print, you cannot delete that using that function. Okay, to delete a folder that contains files, we'll need the shuttle module. Import shuttle, and the function that we're looking for is shuttle.rmTree, short for remove tree, and we will pass in our path. Now be careful with this function, it is considered dangerous because it will delete a directory and all files contained within. So now we can delete a folder that contains files. Folder was deleted. In conclusion, these are three basic functions to delete a file or directory. They are remove, which deletes a file, rmdir, which is an abbreviation for remove directory, which will delete an empty directory, and lastly, rmTree, which is an abbreviation for remove tree, and this is of the shuttle module, and this will delete a directory containing files. So if you would like a copy of all this code, I will post this in the comments section down below. But yeah, that is how to delete files and or directories using Python. Yo, what's going on everybody? It's your bro, hope you're doing well, and in today's video I'm going to be discussing modules in Python, so sit back, relax, and enjoy the show. Alright, well, welcome back. We're talking about modules today. A module is a file containing Python code. It may contain functions, classes, etc. It's used with modular programming, which is this concept of separating a program into useful different parts. We're currently working within our main module, and mine is named Hello YouTube. This is how to create a separate module. Right-click on your project folder, go to New, Python file. I think I'll create a module filled with maybe message functions. So I'll call this Messages, and click Python file. Alright, we have two tabs, one for our main module, mine is called Hello YouTube, and a separate module for Messages. And I can write whatever I want within here, since we're using modular programming. I'll place a bunch of useful functions within this module, and I'll import them to the main module that we're currently working with. Let's define a function called hello. All this will do is print hello. Have a nice day. And I'll create a second function for good measure. Let's call this bye. Let's say bye, have a wonderful time. Now, if we would like access to this module, we need to import it. I will head back to my main module, and at the top, write this. Import, then the name of the module. And for this example, we used the name of Messages for our separate module. And to use a function from that module, type the name of the module, dot, and then the name of the function. So messages.hello will call the hello function found within the messages module. And I can also call the bye function as well. Messages.bye, and that will print bye, have a wonderful time. Now, it can be somewhat tedious to have to write the name of the module followed by the function name. What we could do to shorten things up is to give our messages module an alias, also known as a nickname. So at the top, write import messages as, and what sort of nickname should we give messages? Let's say MSG for short. So we'll replace messages with MSG. MSG hello, and MSG bye, and this would work the same, and it involves less typing. There's also an additional way of importing a module, and it goes a little something like this. From the name of the module, import, and then list all of the functions or classes you would like to import. I would like to import hello, comma, bye. And we no longer need the module name before calling one of these functions. I can simply just call hello and bye directly. Another way in which this could be written is from messages, import asterisk. That means to import all, and I actually would not recommend using this if you're working on a large program or something that contains many modules, because you can run into a naming conflict, because some of these modules may have the same named function names or variables. So if you're working on a small program, I really don't think it's a big deal, but if you have multiple modules, I would actually refrain from using import all. It's much safer to write the name of the module followed by the name of the function that you want to use. Now, another cool thing is that Python has a bunch of pre-written modules that you have access to. If you would like a comprehensive list of them, type help and pass in the word modules. And within my console window, this will populate a listing of all the modules available to us. Here they are. Let's see if math is in here. Yep, there it is. So yeah, feel free to take a look through some of these modules because there's some fairly useful tools within some of these modules. I suppose you can also go to Python's official documentation and search for the Python module index, and here's a listing of all the different modules too that you have access to. Well everyone, those are modules. They are files containing Python code, and they may contain functions, classes, etc. If you would like a copy of all this code, I will post all of this to the comment section down below. But yeah, those are modules in Python. I guess there's a module called Pickle. Hey, what's going on everybody? It's Bro, hope you're doing well, and in this video we're going to be creating a basic game of rock, paper, scissors in Python, so sit back, relax, and enjoy the show. Let's begin by importing the random module, because we're going to need the computer to pick a random choice. And we'll create a list of possible choices. So we have 3 strings within here: rock, paper, and scissors. I think I spelled scissors wrong. There we go. Okay, and we will have our computer pick a random dot choice from our list of choices. And let's test it by printing whatever the computer picks. So the computer picked paper, paper, scissors, and scissors. Okay, what about the player choice? Let's say player equals input rock, paper, or scissors. And let's print what the player has. Print player. And let's print the computer too. Maybe I'll add a string before these. So let's say computer, colon space, whatever the computer chooses. And the same thing with the player. Player. Alright, let's see if this works. Rock, paper, or scissors. Let's say rock. The computer picks paper and I pick rock, so I would technically lose this round. Now, what if the player doesn't pick rock, paper, or scissors? What if they type in gun? So we would like some way to prevent that. So let's put our input for our player within a while loop. While player not in choices. So we're going to need to initialize player because right now it's an unresolved reference. So let's say player equals none for the time being. Okay, now let's test our choices, our player choices. Rock, paper, or scissors. I pick the gun. And it's going to keep on asking me until I pick something from my list of choices. So if I type in that, still won't accept it. Now let's type in rock again. There we go. Now, what if somebody types in one of these choices, either all caps or capitalized? Well, that technically wouldn't be in choices because these strings are case sensitive. So why don't we take our user input and make it lowercase? And I'll just add on dot lower and use the lower method. So therefore, we can now type in any input that is either all caps or uppercase, and then that will still be accepted because we're going to take our player input and then make it lowercase so that it matches one of these choices. Okay, let's work on the win conditions next. So first, let's check to see if we encountered a tie. If player is equal to computer, that means that we both chose the same thing. So let's print whatever the computer picked, what we picked, and we will print tie. Now let's write an else if statement. ELIF player equals rock. So if we pick rock, and then we will create a nested if statement. If computer equals paper, that means we lose. So let's print everything we have here, except we're going to change tie to you lose. Now if the computer picks, let's say scissors, then we win. So scissors, and you win. Okay, then let's just repeat this process for scissors and paper. So this will be another else if statement. If we pick scissors and the computer picks rock, then we lose. If the computer picks paper, then you win. And lastly, we have paper as the player choice. So, else if player equals paper and the computer picks scissors, then we lose. If the computer picks rock, well then paper covers rock and we win. Now let's test it. Rock, paper, or scissors. Again, I'll try and pick the gun, which I can't. Let's take this seriously. I will pick rock. The computer picked rock, so it's a tie. I'm feeling like paper today. Oh, it's another tie, I guess. And how about scissors? Okay, so I win this round. I picked scissors, and the computer picked paper, therefore I win. Let's try and lose this time, just to verify it. So I won again. Let's try rock again. Okay, so I lost that round. So we know that the win conditions are working now. How about we add a feature where we will ask the player if they would like to play again, play another round. I think the best way to do that would be to write all of this code within a while loop. So at the top, let's write while true. And we'll need to indent everything so that it's within the while loop. So let's just indent everything here. Now at the bottom, we will ask the user if they would like to play again, and I will store this within a variable named play again. Play again equals input, and the prompt will be play again. Yes/no. And depending on their input, let's just make it all lowercase. If play again does not equal yes, that means they would like to quit. So let's use a break statement to break out of our while loop that we're in. And at the end, let's print bye. And pay attention to the indentation. This input and this if statement should be within the while loop, so they should have at least one indentation. And our print statement here will just say bye. And you can see that there is no indentation, so that is outside of the while loop. Okay, let's test this one last time. Rock, paper, or scissors. I'm going to pick the cannon. Okay, that's not valid input. How about rock? Okay, the computer picks rock. I pick rock, so it's a tie. Do I want to play again? I'm going to select, actually, yes, all caps. That should still be acceptable. How about paper this time? It's a tie again. Man, the computer's really good at this game. I'd like to play again. I'll pick scissors. Okay, so I lose. I would like to play again. And I want to win this time. Okay, computer picks scissors. I pick rock. You win. Do you want to play again? Nah. And it will print bye. Well, everybody, that's a simple game of rock, paper, scissors. I'll post all of this code to the comment section down below. And well, yeah, that's a basic game of rock, paper, scissors in Python. Hey, what's going on everybody? It's your bro, hope you're doing well. And in this video I'm going to show you guys how we can build a basic quiz game in Python. So sit back, relax, and enjoy the show. To begin this project, I think it would be wise for us to create a skeletal structure for how this program is going to operate, and then we'll fill in the gaps later as we go along. So to begin, let's define all of the functions that we'll need. We'll need 4. We'll create a function that is named newGame. Whenever we call this function, it will create a new quiz game for us. And for the time being, let's write pass just as a placeholder. We'll have a total of 4 functions. newGame, a function to check our answer, a function to display our score, and lastly, a function to play again. All right. Now I'm just going to add some comments here just to separate each of these functions that we have, just so that it's a little bit easier to read, although this part is not really necessary. So I just want to separate each of these functions for some readability. Okay, those are all the functions that we'll need. What we'll need now is some sort of collection to hold all of the questions and answers that we have, and I think a dictionary would be perfect for this. So what I did is that I created a dictionary named questions. A dictionary has key value pairs. Each key is a question that I would like to ask, and each question has an associated value. We'll have the user guess between answers of A, B, C, or D. So these would be all of the correct answers, all of the values within this dictionary. So here are some of the questions that I want to ask. Feel free to come up with your own questions. If you would like, you can copy the questions that I have. They should be posted in the comment section down below. So the questions that I'm going to ask are, who created Python? What year was Python created? Python is attributed to which comedy group? And lastly, is the Earth round? I couldn't think of a 4th question, so I just threw in a random stupid question. And the correct answers to all of these questions in order would be A, B, C, and A. But feel free to come up with your own. Well, we have our questions, but we'll need some sort of collection to hold all of the different possible answers to each of these questions. And I think a 2D list would work perfect for this. So I have a list of lists. A list of tuples could work too, I suppose. So here are all of the answers for the first question. And the correct answer is A. I believe his name is Guido van Rossum. Hey, if you're listening, man, I'm sorry if I'm mispronouncing your name. I'm really trying here. The second list corresponds to the second question. What year was Python created? It was created in 1991, at least according to Wikipedia. Python is attributed to which comedy group? The answer is C, Monty Python, like Monty Python and the Holy Grail. Good movie, by the way. And lastly, is the Earth round? This is a highly debated topic, but the answer is A. The Earth is in fact round. So I have a list of lists. Each list corresponds to a key value pair within my dictionary of questions. And this is a lot to type. If you want, you can just copy the code that I posted in the comments down below. Just copy and paste it and you'll have all of this. Or if you want, you can pause the video and type it. I don't care. So now that you have your questions and your options, we're ready to begin. So the first thing that we'll do within our program is to call the newGame function to begin a new game. So after we have our questions and options created, let's create a new game by calling the newGame function. Now, when we run this program, we'll generate our dictionary of questions and our 2D list of different options for each question, and then we will call the newGame function to begin a new game. So let's head to the newGame function and fill in everything within our newGame function. So at the top, let's declare a few things. Let's say we have a list named guesses, and guesses will be an empty list for now. I will declare a variable called correct guesses, set it equal to 0 because we haven't guessed anything yet, and we will set a current question number and set this equal to 1 to represent the first question. Okay, now we need to display all of the questions within our dictionary of questions, and we can use a for loop for that. So for key in questions, I'm going to print my key. And let's just test this. Okay, yeah, here's all my questions. I think what I'll do is actually print something to separate each question. Let's say one of these lines. I think it would look better with them. Okay, I'll print this line, and then we'll move on to a question. Alright, now after rerunning this, we have each question, and I added just a line break between each of these to make it look kind of fancy. Now, I need to display all of the different options for each question, and we can do that with a nested for loop. So if I were to write for I in options, print I, let me show you what happens. Now, with the way this for loop is written now, it's going to display all of the different options available to us for the entire quiz game. What I would like instead is to display only the first list for the first question, and then the second list for the second question, and follow that pattern. So we're going to change our for loop around. For I in options, and we'll set an index for options. The index is going to be our question number, -1. Now, remember what I said in previous videos where different collections, including lists, tuples, etc., the first element in a collection has an index of 0 because computers always start with 0. Then the next element would therefore have an index of 1, then 2, 3, then you follow that pattern. We're using this question number variable as some sort of counter, and since we initially set this to 1, I'm just going to subtract 1 so that we effectively receive 0 as the index. And now we just need to increment our question number after each iteration. So let's do that. I will add that to the end here after we finish displaying all of the options. Let's increment question number by 1 by typing question num plus equals 1. And if I were to run this currently, we'll display all of the different options for each question. Who created Python?